Well, good afternoon, everybody. I'm honored to be a part of this year's conference. I've spoken there in person in the past, but regrettably couldn't do it this year. I'm in Maryland. So a couple of things. So you see the code up front. If you have any questions, and I certainly hope you will, you can type your questions in, present your questions through that utility. I will do my best to get them all answered this afternoon, excuse me. And if there's anything left over, I will certainly be providing the team with written responses to any and all the questions. That being said, let's see what's going on here. Okay, yep, let me back up. You have a link to my presentation. I would like everybody to take the time to download this presentation. When I'm finished with what I'm going to be speaking here, there are 13 additional slides in the presentation that give you the step-by-step on how to use the NGS beta tools to compute the new state plane coordinates and the new heights for the new datums that are coming. And I just don't have the time to go through them step by step in this brief period this afternoon. So please download them. And if you have, again, once you've downloaded them and you get home and you want to play around with it, if you have any comments or questions, you have my contact information here. Do not hesitate. Call me, email, text, whatever works for you. Okay, so let's move on. The National Geodetic Survey has been planning the release of these new datums literally for 19 years. Right? This is an incredibly big step. Changing national geodetic datums is no small feat. This time around, some things are being done that have never been done anywhere else in the world before. So this is an exciting time. A couple of elements here. Issues that you can start to talk to your clients about. So what are the problems? Why do we need to change? One of the biggest ones, of course, is that N8083, our current national geometric datum, that is latitude, longitude, and ellipsoid height, three-dimensional, is biased to our best global definition. That is, it's not as geocentric as it could be by roughly about 1.5 meters to 2 meters. You'll see this in a few minutes. That goes all the way back to the 70s when we designed the datum. It was the first datum, horizontal datum anywhere in the world to be designed to have its origin of coordinates at Earth mass center. No country had ever done that before. And obviously everything we did was in collaboration with our neighbors to the north, the Canadians. At the time, our knowledge of the location of Earth geocentered was roughly about 2 meters, 7 feet almost. Today, with the advances in positioning technology and global collaboration, we now know the location of Earth geocenter to better than 2 centimeters, less than 1/10 of a foot. So it is time. We need to make this transition. So that's one big aspect of it. On the vertical side, NAVD88, North American Vertical Datum of 1988, has been defined, is realized, as the term we like to use. It's realized by the passive marks, the benchmarks, the brass caps. That is how it's realized. Meaning, if you actually want the datum, you literally have to go to the brass caps, wherever they might be. And unfortunately, over the last 30, 40, 50 years, NGS has not done a considerable amount of leveling. Now, some areas around the country, states have picked up and done a bit, but nothing consistent. And increasingly, we want to be able to rely on the contemporary tools we have, such as GPS, GNSS, which is three-dimensional. We want that vertical component, which means we have to have a consistent geoid model, which we do not have at this point in time. Geoid 18, which is a terrific geoid model for the United States, is good in some areas. Parts of California, Minnesota, Puerto Rico is pretty good, New Jersey's pretty good. A lot of other places, not so good, simply because The definition of it was realized by obtaining GPS on those physical benchmarks to create a surface. And that just was not consistent across the country, never has been. So consequently, the accuracy, the integrity of our geoid models is not consistent from one end of the country to the other. And additionally, all heights, in fact all coordinates, and one of the wonderful things I love about talking to surveyors and others in our community in California is when I say things are always moving, everybody out there gets it. You know everything is moving. It's your day-to-day. And so we see this consistently with both heights and positions. And it's important that we now have utilities and tools in which we can more accurately manage and understand what those motions are about. And that's a big part of what the new datums are going to do for us. So one aspect are improvements in GPS. Obviously, we are now in the GNSS world, Global Navigation Satellite Systems. But right now, the United States is in the process of updating GPS. We're launching the Block 3 satellites. We currently have 8. The material that I presented to the students, you can download. It says the next launch was going to be, well, maybe we thought it was going to be late last year. Well, that didn't happen. It's supposed to be the first quarter of this year. That'll make 9 Block 3 satellites. And the Air Force has already said the system will go live when they have 10. So I'm hoping that by the end of this calendar year, we might have 10 Block 3 satellites, and the system will be operational late this year or early next year. So we're in the process of looking at some really fundamental changes in real-time positioning with no ground control, as you see at the bottom. Notice also my question mark. I don't know what the dates are going to be. I just know we are headed there. And when that happens, it's vitally important that we be in the new datums. Because if we're not, that 1.5 meters that NAD83 is biased by will pop right up, right? And we want to be ahead of the game, not trying to play catch up. So the new datums have names, right? We will have 4 geometric datums, that is latitude, longitude, and ellipsoid height, or commonly referred to as horizontal datums, because the United States and its states and territories exist on 4 different tectonic plates, of course, and they're moving at different rates and in different directions. So NGS is managing 4 different reference frames in this. What we currently refer to as NAD83 will now become the North American Terrestrial Reference Frame of 2022, or NATREF is the working acronym. The really cool thing, and I think this is way, way cool, the really cool thing is now, for the first time, the United States will have one consistent vertical datum everywhere. That is, from Maine to Guam, we will have one consistent vertical datum. NAVD88 and the island datums, because each of the islands have their own local vertical datums, will now become a singular vertical datum, the North American Pacific Geopotential Datum of 2022. And notice it does not say vertical, it's geopotential because it's built entirely with gravity data. There's no leveling at all in the definition of the new vertical datum. It will be realized exclusively by a geoid model. Geoid 2022, which is out there in beta form for you to go look at. The horizontal positions are all now defined relative to ITRF 20. That's out there for all the cores. So all of these elements are there. It's a matter of putting some of these pieces together, and will very likely go live, if not official, by the end of this calendar year. I should also notice California, obviously, is a coastal state. You will be getting a new national tidal datum epoch coming in 2029. The handout material says 27. Just within the last 2 days, I found out that's been pushed to 2029. So that's something you're going to be wanting. Those of you who work in the tidal environments, you're going to want to be aware of, following this, and making sure your clients are aware that those changes are coming as well. Everything is built now around what I call the international gold standard. and that's the IERS, the International Earth Rotation and Reference System Service. They're headquartered, as it says, out of Paris. They're the ones who define, who build, and distribute the ITRF, the International Terrestrial Reference Frame. The first one was in '88, the current one is ITRF 20. All of the NGS cores are now defined in ITRF 20, and that will be the foundation for the new geometric datum. So we're already there. Now it's just a matter of integrating that along with many of the tools that the vendors are providing. So that's a big part of what NGS is working on right now. There are 4 different measurement technologies that are used globally. These are, the IERS doesn't own any of this stuff. They simply manage data that is managed itself by other services. GNSS, satellite laser ranging, the VLBI, very long baseline interferometry, and DORIS, Doppler orbitography and radio positioning integrated on satellites. All 4 of these technologies working together give us the best sense of what our Earth orientation parameters are. Those things such as, where is Earth geocenter? What are the velocities, horizontal and vertical velocities of the various tectonic plates around the world? So they provide the ITRF, they share it with the world. It's then up to individual states to decide how they want to integrate that. Here's an example of what these changes are going to start to look like. Here's the first example of what positional differences are going to be. I just pulled down an NGS data sheet for cores that's very close to where you all are, and you'll see that the horizontal position between ITRF 20 and the current NAD 83 2011 is about 1.5 meters, 5.2 feet, and the ellipsoid height 0.7 meters, 2.5 feet. Notice though, of course, in California, while you do have NAD 83 2011, you have a different epoch, because you work with, many of you work with the California Spatial Reference Center, and that's an important group to be working with out there. They will handle things a little bit differently in California than most of the rest of the country will. So you need to be paying attention both at NGS and the California Spatial Reference Center. So we already have ITRF 20 defined in the cores network. If you simply go back and take the position I had previously, if you look at the X, Y, and Z Earth-centered, Earth-fixed positions, you simply difference them, add them, take the square root of the sum of the squares, there's that offset, 1.7 meters, 1.8 meters in Fresno, most of California. So that highlights that offset between NAD 83 and ITRF. The big transition, why it's taken a considerable amount of time, really is all about the vertical, and that is the attempt, not just the attempt, but the completion of completely flying airborne gravity across the entire United States. And when I say that, I don't mean just CONUS, the conterminous US and Alaska. I'm talking the end of the Aleutian Islands, which is way out there. Places like Guam, the Northern Marianas, American Samoa, certainly Puerto Rico and the Virgin Islands. So we now have a gravity map of the United States, which will define how we create heights in the future. And just very quickly to go through this, at the top level you have the space-based platforms, gravity recovering climate experiment, the GRACE satellites that are constantly collaborating, collecting the gravity for the entire world. Also the Gauche mission that the Europeans put up for a while. That gets integrated. The global picture gets integrated with the airborne measurements, which are fixed to the ground using absolute gravity observations. You see a couple of pictures there of 2 different gravimeters, gravity meters, an FG5 absolute meter and an A10 meter. So all of these things working together give us now our picture, our snapshot of what the Earth's gravity field looks like over the entire United States, Canada as well. In fact, it'll cover a significant portion of the Caribbean when it's done. So we hopefully have a consistent geoid model over a significantly large area. So that's the background behind it. Since in my limited time here, I want to highlight this because this is what many of you will deal with ultimately, transitioning from current sets of coordinates to what the new ones will be. You will either reobserve or you will transform using some kind of tool. Notice that, first of all, you can't improve a position or a height by simply performing a transformation. Whatever you have, whatever the accuracy you have going in, that accuracy will be there, and potentially some other error. Need to know how good the transformation tools are. I can say without a lick of hesitancy that I am quite sure that the geometric transformation, that is latitude, longitude, ellipsoid height, consequently state plane coordinates on the ellipsoid height, that NGS will develop, will be spot on. I believe it will be at the millimeter level across the United States. That one's going to be terrific. The one I worry about is the vertical, because the vertical transformation is going to be based on the collection of GPS on benchmarks that have been provided to the National Geodetic Survey. And right now there's lots of areas that I see around the country where not much was done. So notice here that in the slide, I've got this as my estimate. I highlight that in red. These are my estimates. These do not come from NGS. NGS has not propagated any estimates on what they believe the vertical transformation will be. My suspect is because it's completely involved with GPS on benchmarks, GPS on known NABD88 benchmarks, that we are likely to be in the range of 2 to 4 centimeters in areas where there's a considerable amount of this. So just very quickly, and I've given you a URL there for the GPS on benchmark page that NGS has. You can go to it, you can look at any part of the country. I'm just going to highlight the area where we're looking at now. What I see, when I see areas that are dark in the map, that tells me there's good data there. Notice all the other icons, the icons in blue, the icons in yellow. Those are icons representing benchmarks that NGS asked for data and did not get. So when I see areas that have lots of icons, those are the areas I worry about, that the transformation will be larger. If I see the areas dark, that's probably going to be on the good side, right? So take a look at that map, depending upon where you're going, where your clients are around the country. Take a look at that map. It'll give you a pretty good idea of what the integrity of that transformation will very likely be when it goes live. On the state plane coordinate side, I hope everybody is well aware the U.S. survey foot is gone, never to appear again. Everything will now be in what we've commonly referred to in the past as the international foot. NGS will simply refer to it as the foot. Right? And you can see from this map that now we're going to see considerable changes in the state plane coordinate system around the country. So currently, California has 6 zones, you're going to get 9, and those 9 zones have been redefined such that they will essentially be low distortion projections. Now, in some areas it might not fit the bill because California is a big state and there's only 9 zones. But I think many of you will be very surprised and pleased that in most areas of the state, when you're using the new state plane coordinates, you will essentially be working in a low distortion projection. If you're working in other states, and I'm sure many of you do, take a look at the map. You can download the map from the NGS beta tools, and you can see what's going on in other states. So look at your neighbors, like over in Arizona, they're going to have 63 zones, or Oregon, and 40 zones, Ohio, 89 zones. So a lot of states are doing something considerably different than what they had with NAD83. What I've done here is I've just picked a single point that's relatively close to Fresno, and I've run it through the NGS beta tools to compute what the new coordinates are going to look like. So from a horizontal perspective, the positional change, roughly about 1.5 meters, 5.2 feet in lat long and UTM coordinates, for those of you who might be working in UTM. For those of you working in state plane coordinates, if you're looking at California Zone 4, which is where you are now, the change, the magnitude in the change in state plane coordinates is going to be knocking on the door of 5 million feet. So be aware that, okay, all of a sudden, you're going to have big changes. California is going to get something that every state will have. Some states have had it already, like Maryland, where I live. A small state, we've always had a single zone. California will also have a single zone. We anticipate the users, a lot of GIS users or people who are doing projects over long distances. So if you use the statewide zone, which never existed before in California, now the magnitude difference at any given point right there near Fresno will be closer to 800,000 feet. Right? So it's important, I think, to look at what the magnitude of these changes are going to be wherever you have projects that you're working on, you have clients you have to deal with. Changes in the ellipsoid height, again, in your area, almost 2 feet, and the changes in orthometric height, that is from NAVD 88 to the North American Pacific Geopotential Datum, will be about 2.4 feet, almost 2.5 feet in your specific area. It'll vary a little bit, of course, across the state. And of course across the country. So the tools that are out there, the beta tools that I'm sharing with you later on in this material, will allow you to go in and compute that. You can use this as an example if you want to go in and just compute one up and make sure you're doing the right stuff. Here's one of the big things. So I took the new state plane coordinates from this point that's very close to Fresno, and I said, let's assume I'm going to use, I'm going to measure a distance that's 1,000 feet, and I'm using the current NAD 83 2011 Zone 4 grid distance, the combined factor. That gives me a grid distance of 999.94 feet, so 6/100ths of a foot off of my horizontal distance. If I'm using the new zone, the North American Terrestrial Reference Frame 2022, Zone 4, it is the horizontal distance. There is no difference. If I'm using statewide values, well, of course, it's going to be considerably different. So that right there, it tells you if you're working in and around the area of this conference, you are essentially now in a low distortion projection. And you can do the same thing in any other zone, anywhere in the country. You can get a sense of how good they are going to relate to essentially what we now refer to as a low distortion projection. Running out of time here. One of the critical things is mining your metadata. Make sure you know what your data is about. Whatever you've got, your clients have got. Very quickly, I've just given you a list. I've run through my time for speaking. We need time for questions. But make sure you know the datums and the realizations that you have, what units of measurement are, and I'm pretty sure most of you got it, and how accurate is your data really? Notice what I've got at the bottom. The number of digits, the rate of the decimal point have nothing to do with accuracy. So ensuring the integrity of your data, making sure people know how good that is, I think is a vital piece of moving forward. What I've done in this slide is just put up some examples of what I call bad metadata that I've gotten from professional sources. And again, given the limited time we've got here, I'm just going to highlight one, and that's the one in the middle, which is the north arrow. All surveyors love a pretty north arrow. Well, that's a very pretty north arrow, but the surveyor who put it on his plat said it's reference to NAVD 88, the North American Vertical Datum. I'm not quite sure how you get north of a height. So again, bad metadata, stuff like this exists out there. I'm sure many of you have seen things like that. So I just put these out there as examples. If anybody's got questions, you can get in touch with me. I'll be happy to talk to you about this stuff. Here's a big deal. Talk to your vendors. Know what they're going to do. I've given you a list of things that I think are critical questions. Are your current units already L5 capable? L5 is the new signal we're all going to get. How long, those of you who are dealing with real-time networks, how long will they maintain two datums, NAD 83 2011 and NatRef 2022? What I'm hearing from, at least from NGS, is probably not more than a year. So you may not have a long time to make these transitions. And datum transformations, because most of you probably won't use the transformations that NGS provides directly, you'll use whatever comes from your vendors. Make sure they are using exactly the same transformations that NGS has. So just some questions for you to go out and talk to them about, since you're very close to them right there. And I've also given you some elements here. If you're not already on the NGS mailing list, please do that. Be a subscriber there. They try to have a monthly webinar that talks about the new things. As it says, pay attention to what's going to be going on with the California Spatial Reference Center and how they're going to deal with this. They're a big player, of course, in collaboration with NGS, and you are exceptionally lucky. You have one of the few remaining NGS regional advisors, Dana Kakamesi. Dana's a terrific guy. He's an exceptional person out there. However, he is just one person. So he's got a lot to do. So make sure you get ready to understand what's going on with the new datum. We didn't have much more to say. That's the end of what I have. And they told me to leave some time for questions, so I'm ready if anybody's posted anything. I know that was quick. I apologize for that.
Okay, thank you, Mr. Doyle.
Sure.
We have two questions that are posted.
Good.
I'm gonna hide you so I can display these questions.
Sure.
The first one is, how is NGS integrating? How is NGS integrating the GPS on BMs in the new reference frame realization?
So NGS will in fact perform a national adjustment of all of the passive control, the GPS on benchmarks. The GPS on benchmark tool, what it was designed for, previously it was designed to build the GeoID models. Since the release of GeoID 18, all of the GPS on benchmarks now will be directed towards improving the vertical transformation. So those results will show up as the actual vertical transformation going from NABD88 to the North American Pacific geopotential datum and vice versa. That's why I said, look at that map. I've given you a link there. Go to the GPS on benchmark page from NGS. Look at the areas that you might be interested in. If they're dark, that means NGS got a lot of GPS on benchmark, and the transformation itself will probably be pretty good at the 2 to 3 centimeter level. In areas where there isn't much of that, you see a lot of those icons, that's an area where you may have to worry about how good the accuracy of the transformation will be. Next.
Okay, and then we have one more question.
Yep.
What is the reason behind so many zones for certain states?
Really good. That's a very excellent question. What NGS did, first of all, NGS doesn't do anything with state plane coordinates. I was chief geodetic surveyor for 12 years before I retired. I can pretty much tell you that at NGS headquarters in Silver Spring, Maryland, they probably have 5 people who can even spell state plane coordinates. They don't use them. Right? So the state plane coordinates are designed for you. And what happened this time around, a brilliant young man, Dr. Michael Dennis, he reached out to all the states and said, what do you want the systems to look like? So the states put together their own teams that included the Land Surveyors Associations, the state DOTs, Caltrans, I'm sure state groups working with GIS to say, what do you want them to look like? And most states said, we want zones that look like a low distortion projection. So that the difference, that is that grid to ground issue that surveyors have talked about for years and years and years now, that to one extent or another, most states, not all of them, most states built larger new systems that are designed specifically to act very much like a low distortion projection. That's why you see some states with so many. Now, how you manage that? That's going to be up to the surveyors and other managers in each state on how you do that. That's a pickle I won't have to deal with, but that's why. And so NGS didn't do this on their own. They went to the states.
Okay, and that's all the questions we got submitted, but
Okay.
also all the time we have. But
Sure.
if everyone could give Mr. Doyle a round of applause.
Please, I hope you guys have a great conference. For me, it's always a great conference. I'm honored again to have been a part of this, and I look forward to maybe talking to some of you a little bit later on. Again, highlight, you've got my contact info. If any questions come up later on, email, text, call, whatever works for you. Otherwise, have a great time. Bye.
All right, good afternoon, everybody. My name is Eric Albanese. I'm a principal land surveyor with Pacific Gas and Electric Company. I have two main jobs inside PG&E. My first job is leading PG&E's remote sensing team, and my second job is maintaining PG&E's geodetic network and ultimately our real-time network. And today I'm here to talk about how PG&E is maintaining our real-time network and how we're approaching the issue that Mr. Doyle presented on with movement inside California. PG&E has I'd say a pretty unique approach in that we are applying a dynamic ethnic approach to our real-time network. So I'm here to give you a little bit of background on our team and then discuss how we're going about doing that and how we're monitoring that, and then some of the pros and cons between why we're doing that. All right, this is our remote sensing team. We are system-wide, so we cover pretty much the entire state of California from the Oregon border all the way down to Arizona, the Topac area, since we have gas lines that go all that way. There's 12 of us on the team currently. We do everything from close range photogrammetry, structure for motion, to wide area LiDAR, corridor LiDAR, UAS LiDAR, terrestrial photogrammetry, and everything in between. PG&E has 120 surveyors in the company, and about 42 of those are PLS in the company. What tools do we use? So you can see PG&E's fixed-wing aircraft on the top left. They have the blue PG&E tail up there. Those both have Optech T2000 Galaxy sensors in both of them, where we dual collect topographic LiDAR as well as RGB and near-infrared 4-band imagery. We have, I think, 12 to 13 terrestrial scanners. We have a whole bunch of drones from DJI to every potential manufacturer you can think of for all of our photogrammetric work. And on the Optech side, for our drones, we use CLSA LiDAR sensors. All right, to give you a little background on PG&E and our service territory and how much we actually fly, we have about a 70,000 square mile service territory. We fly about 10,000 of that every year from a wide area perspective, and that is for things like system hardening and undergrounding. If you've heard of the 10K underground effort that PG&E is undergrounding our electric lines in high fire threat areas. Our team produces all the base mapping, aerial LiDAR, as well as orthoimagery for that. We have a whole contract workforce that closely works with us, and we greatly appreciate our contract workforce as well. Some of the other big things, we have about 19,000 miles of electric transmission lines. We fly that twice a year. We produce full-scale engineering PLS CAD models on 19,000 transmission miles every single year. And we have 107,000 miles of electric distribution. We fly about a quarter of that every year for base mapping purposes, for pole loading, for system hardening, for conflation efforts, and everything in between. We have about 6,500 miles of gas transmission that we fly yearly for temp and HCA purposes. So temp and HCA are how much pressure we can put into our gas transmission lines, and then temp is the integrity management of our gas lines. So we want to know if there's subsiding areas near there, if there's landslide, debris flow issues near PG&E assets. We also fly a good amount of our gas distribution, but that's more standard survey work that we would do for a new installation of gas distribution, potentially capacity jobs and replacement jobs. Right, so what we're here to talk about mostly is PG&E's current geodetic network and ultimately the dynamic approach that we have. So PG&E has 41 internally owned real-time network or core stations that are operated by our team. We also utilize about 40 external stations. We are a consortium member with the California Spatial Reference Center that Mr. Doyle talked about, so we work really closely with Yehuda and team down there. We plan to add about a station or two every year. I have two sitting in my office right now, ready to throw out somewhere when I find a good place. We hook up all of our core stations, and I'll give you a couple of examples of what they look like here in a second, to PG&E's UDN, which is our Utility Data Network, our internal intranet. The reason we do that is it's very low latency compared to cell service, and I'm sure a lot of you have worked with core stations in the past where you've used cell service, and it could be good sometimes, it may not be good other times. And then our current epoch that PG&E sits on is 2026.0. Our prior epochs are 25.5.0 and 24.5. We are updating our epoch every 6 months due to the movement, the interframe velocity inside of California, or when there is a large event that affects one of our stations more than 2 centimeters. And so for FGDC requirements, we have to have a 2 centimeter network accuracy, and if a station goes out of that, we're going to publish what we'll call special epoch, maybe a 2026.1 or something like that, depending on that. All right, this is what a typical PG&E station looks like. The vast majority of our stations are frame building mounted stations. We have a couple braced monument stations, but the vast majority are building mounted stations. Since we are a utility, we're not in the science community. If we have a little bit of movement, maybe a couple of millimeters of these stations due to building movement or vibration, it's not the end of the world for us. But the other part of all this is, I don't know how familiar you guys are with Trimble Pivot software from an RTN perspective, but we use Trimble Pivot to, sorry, just making sure I have 2 screens here to make sure I'm synced up properly. We do all of the modeling of our network, and so we do geometric modeling and ionospheric modeling of every station every single day. And I really want to talk about the geometric side of things, because if we don't have an updated epoch and we let our stations from an older epoch go out of tolerance, geometric tolerance, then when we're modeling the geometry between these stations and actually propagating or correcting that for the users in the field, we're going to introduce a lot more error. And so having an updated or dynamic epoch really enhances the correction, the accuracy, and the precision of your location out there in the field. All right, so let's talk a little bit about velocities. So on the left is ITRF 2020, on the right is the new NatRev 2022 that Mr. Doyle talked about. And so ITRF 2020, we have a very large rotational component going from east to west inside of the United States. That component is largely removed by the NatRev 2022 or even Nat 83 2011 realization. But as you can see, we're still left with a lot of additional velocities. And those velocities are what we call intraframe velocities inside California. And it's probably hard to tell, but on the bottom down there, we have anywhere from, on the east side of the San Andreas Fault, 5 to 10 millimeters of movement. West of the San Andreas Fault, 20, 30, in some places 50 millimeters. So we have a lot of movement every year that if we try and hold static coordinates on, from a PG&E perspective, we have all of our assets from transmission lines, distribution lines, both gas and electric, cross fault lines constantly. And so our engineers and surveyors, it's a constant challenge for us. And so the solution that we've come up with, Caltrans has their own solution, we have our own solution as far as dealing with that, and our solution is updating our epoch every 6 months. All right, before I get into how we do that, I want to talk a little bit about the pros and cons of a dynamic epoch and a dynamic network. The main pro is it improves your positional accuracy. You are where you are. And if you're going to use an updated epoch, your coordinate, your absolute position coordinate is a lot more accurate than where it was 6 months ago, a year ago. We are moving. California is moving quite a bit. The other thing is, which is a fantastic thing for PG&E with how much LiDAR data we have going back to 2010, PG&E, we have about 10 petabytes now of remote sensing data stored inside AWS from 2009, 2010 forward. And when we want to perform change detection to know how much our towers are leaning, how much more subsidence there is in an area, how much more cut or filled, maybe depth of cover on our gas lines, we can reprocess that data from 2010 all the way forward. But in order to do that, we have to know the position of the station that we are referencing to move that forward or back in time. And I'll talk a little bit more about that. But without a dynamic epoch approach, you're going to be propagating that error even further. I talked about the geometric errors in our RT and our real-time network, and so these geometric errors, if you have an updated epoch, are going to be a lot smaller when we propagate out. And then the last thing is it facilitates long-term consistency and monitoring of our projects. But with saying that, one of the big cons, which I hear about almost every day from some of our 120 surveyors in the company, is the increased complexity of coordinate management. We have an entire webpage dedicated to our surveyors with every epic approach from all of our RTN stations and our core stations, both public and private. The deltas between those stations, so you can get a discrete coordinate approach from epic to epic. We also publish potential or velocities for each of those stations. The other main risk is just user error, using the wrong coordinate, using the wrong epic for that. And then the one that I hear about the most is really the complication of local engineering projects. Most surveyors don't care because your local project is moving in the same direction. The entire site locally is moving together. From a PG&E perspective, we have a ton of local projects. We do dam deformation surveys, we do crack monitoring, really high precision structure for motion or close range photogrammetry. And those, the easiest thing for us is we just hold a particular epic. It doesn't matter, we'll hold 2024.0 for the life of the project. But for our large scale statewide projects, we just don't have the luxury of doing that because things are moving. So we need a method to rectify that. And then the last thing is legal requirements. I'm guessing I'll get a couple questions on that about the Public Resources Code. Legal requirements, we do publish official 2025.0 coordinates for all of ours, plus the older published epics of 2017.5 and 2010 by CSRC. So if we need to file a record of survey inside PG&E or publicly record something, we will abide by that. But for internal PG&E work, we are utilizing that dynamic epic approach. All right, everyone's favorite TBC. And so, like I mentioned, every 6 months we are updating it, or when there's a large event. How we go about doing this is we hold anywhere from 32 to 34 CSRC stations that are weighted constraint in our network, and they're geometrically set up around PG&E service territory, and we have quite a few in the middle. We try and limit our baselines to 20 to 30 kilometers max for all of those stations. We seed our large-scale network adjustment in StarNet with the coordinate standard deviations from CSRC. We use 5 24-hour five 24-hour days RINEX files, and we skip a day in between within 1 to 2 weeks of the proposed epic. And the other piece, for those that have used TBC and do a lot of baseline processing or network adjustments, is we look at the expected accuracies of the baseline processing inside of TBC, and then we look at the actual RMS values that the baseline processor does come up with, and we use that as our potential factor in going directly into StarNet. As everyone knows, TBC likes to, and I hope there's no Trimble reps in here, but Trimble and other vendors, they really like to overestimate the actual amount of error in their baselines. And so we use that as a gauge for the actual RMS values relative to that as a potential starting point, I'll say that, to seed our least squares adjustment. All right. So what does a good station look like from CSRC that we want to utilize as a coordinate basis and a hold so we can propagate that velocity forward? We want very stable stations that when we look at their time series, there is no movement that beyond maybe a millimeter or two. And in fact, we have some specifications where the velocity profile is a sub half a millimeter horizontal and 1 millimeter vertical at 1 sigma. We do a visual observation of these and make sure that from a visual standpoint they look good. And then the main point of this is, the main factor is we need to look at stations that have less than a 2 millimeter horizontal standard deviation, coordinate standard deviation published by CSRC, and less than 5 millimeters vertically. Because then we know that we're constrained to stations that are very tight, they're very stable, and they have moved forward through time over the last 10, 20 years in that same fashion. What kind of stations do we not want? There is a lot of stations, especially in the Central Valley, along fault lines, along areas that their time series does not look great. You can see the red line in there. That is CSRC's modeled position of that core station. We want to stay away from these. We'll use them as additional geometry and additional weight inside, but we're not going to hold them. We'll free those coordinates and we'll look at the published coordinates versus what our coordinates are to get a good idea. But ultimately, we're not going to hold them. We'll use them for, like I said, additional redundancy in certain areas. And those are really just the opposites. Anything greater than 2 millimeters horizontal from a coordinate standard deviation standpoint and 5 vertical, we're going to throw those out. There is one station up near Eureka we have to hold just because it's really the only station up there. But That's Eureka. It's a unique place up there. All right, that is how we calculate it, but you may be asking, how do we monitor this state? How do we monitor this to make sure that we are on 2026 moving forward and our stations are not moving? Well, we do it in 3 ways. Every single night, one of my favorite things to do in the mornings, like Christmas morning, every time I wake up, is I get to look at the results of our network adjustment every night and pivot. We do 24 hours of data every day. We process it in a giant baseline processor. We hold 3 stations from CSRC and their published velocities on the north, the center, and the southern part of PG&E service territory near the Grapevine. And we hold those as fixed. And we look at every other coordinate based on those 3. We look at the time series, which is updated weekly by CSRC to make sure that there's no movement. That's one way we monitor. Second way we monitor, and here's a pro for the Trimble reps, and here I'll give it back to you a little bit, is we use RTX. RTX, we feed 24 hours of static data into Trimble's RTX monitoring system. Trimble's RTX, as you may be aware, is a true date system, so you're getting your survey date and whatever file you input into that as your coordinate. We only use that for the horizontal component. I don't know how many of you have used RTX in the past, but it's pretty good horizontally. Vertically, it is very wild, depending on how much data you give it and the time of day. But it gives us a very good idea horizontally if and where these stations are moving to. Lastly, we do 2 what I call live trackers. They're 1 hertz every second. We are getting an updated coordinate from an RTK and an RTX perspective. So we're looking at real time for earthquakes, anything. If there is an earthquake, or God forbid, one of our telecom people kicks an antenna or something up there, it'll immediately kick it out of the network, and we'll reconfigure the network based on that until we can get that coordinate within tolerances again. So we have alarming enabled, and we actually have disable. We disable that station if it were to go above that 2 centimeter tolerance that we're required to maintain. And then this is just a graph of what those look like in a spread. We can look at it in all sorts of fun ways if you're familiar with that. Just another look at this. It kind of shows the jigsaw happening here. This is for a couple of our stations. You can see that they started at 0. I don't know how well, it's probably hard to read on the left over here, but they start drifting over time. We get to about that 2 centimeters, which for most stations in California is about 6 months, especially west of the San Andreas Fault. We readjust back to 0 again, and they start spreading apart again. And we see this constantly. And this, the green one on the bottom, that is one of our stations on the San Andreas Fault, constantly moves, we adjust back. Constantly moves, we adjust back within that 2 centimeter tolerance. The other thing too that I really want to point out here is when we do our change detection, if we're doing change detection from, let's say, a 2015 LiDAR survey, and we just did one today at 2026, there's 2 different ways you can move data sets. You can do a discrete coordinate movement from, we could pull the 2026 coordinate, we could pull the 2015.0 coordinate on that, and we could just shift the entire point cloud by that. That's only good if your velocity profiles are very similar for the whole project area. So if it's a very local site, it's probably going to be fine. If that site crosses the San Andreas Fault at all, or any subsiding areas, it's not going to work. But what we can do is, since we have the raw data, we have the initial trajectory data, we can actually reprocess the entire trajectory, which holds consistent the internal geometry of that survey, reprocess that through your favorite trajectory software. We use POSPAC inside PG&E, another Trimble product. And then actually, when you do that way, you're going to maintain that internal geometry, and then you're going to have true change at the true date, or whatever epoch you want to compare against. So that is the other reason we maintain this giant coordinate database for PG&E, so we can look for things like that. Depth of cover is a big one for PG&E, how much dirt is on top of our gas transmission lines. All right. Change detection. So here's just a couple of examples of some change detection. The tower on the top left, that's a tower that sits on one side of the San Andreas Fault, and we love looking at it because it always just keeps moving away. And it's in an area and kind of in the Oakland area, and our engineers just love this tower because we're constantly having to work on it all the time, and it moves, and it moves, and it moves. But without what we're doing, there's either 2 things going to be happening. We're going to be moving back in time, and we're either going to process the left side of the San Andreas Fault or the right side. And one way is going to move it back further than the other. When we hold a dynamic epoch, as PG&E does, we can process trajectories, surveys with either station. It doesn't matter at this point because we are getting an up-to-date coordinate on that. And the real geometry between our LiDAR survey or our terrestrial field survey will be the same with this approach. The other thing we do is we do tower lean for the entire company every year. Part of that's 18,500 line miles that we fly. And we quantify how much lean each tower and pole in PG&E's service territory has. So on the bottom down there, that bottom photo, if it's yellow, orange, or red, that dictates how much out of plumb that tower is, from tower center bottom to tower center top. And we will quantify that. And that gives our engineers a really good approach at, all right, where are the issues? And you probably guessed that a lot of these issues are near fault lines and subsiding areas because one tower is pulling on the other tower or vice versa. And then lastly, with this approach also, landslides, debris flow, which we have an entire geoscience department at PG&E that is their main concern for anything that could impact PG&E's assets. And it's a really good approach. It's taken about 2 or 3 years to get most of the surveyors on board within PG&E, but it's going pretty good. This was a really interesting use case. I'm not going to dive into it just due to time here, but if you want to swing by and talk to me about it at the PG&E booth, I'd be happy to. I can also send you this article, but PG&E partnered with Cal Poly Pomona after the Ridgecrest earthquake. We have 2 gas transmission lines that go right through there, and it was a very interesting project, and it details exactly how we monitored from previous LiDAR surveys, exactly what I'm talking about right now, to LiDAR surveys after and how we mitigated the approach moving forward. But it is public information, so if you want a copy of it, just let me know and I'll send it to you. And then lastly, some of you might be asking, well, how well did I do, right? Compared to CSRC just published the 2025 Epoch in August of last year. PG&E published our 2025.0 Epoch January 2nd, 2025. So how well do our coordinates fit published coordinates? Because ultimately that's all that really matters at the end of the day. Is the approach that we're doing a good approach, or is it incorrect, right? Does it need to be adjusted in a certain way? Well, the top one, the green, is, I just projected these to a UTM system for ease of looking at it. Green is our X coordinates and Y are yellow. All of our stations, 32 of the 35 stations in the X components, are less than a centimeter, and actually the vast majority are less than half a centimeter from the published CSRC coordinate to PG&E's. And in the Y, it's even better. It's 33 out of 35. There's only 3 stations that deviated slightly above a centimeter and slightly below a centimeter and a half. Those are 3 stations near Eureka. If you remember, I talked about that one particular station. Also, something that happened near Eureka at the end of 2024 was the Cape Mendocino earthquake, which shook up quite a bit up there, all the stations. And if you actually look at the modeling tool from CSRC called Sector, you can actually see they readjusted their model right after we adjusted. And so that's why we're about a centimeter and a little bit off. But at the end of the day, a centimeter for PG&E, when you're doing an RTK survey, it's already lost in the noise of the RTK survey anyway. The black lines going north and south or up and down, those are the error bars, standard deviation error bars. Every single one of those is within tolerance to the published station. So we may be off a half centimeter by our published, but the error bar from published CSRC stations fits well within tolerance. And then lastly is the Z component, which is the fun one, and then ultimately the 3D component. So 31 out of 35 in the Z components were all less than a centimeter. And that's the ellipsoidal height. In fact, it was about the same thing, about half a centimeter. Every single error bar intersected it except for 3 or 4 stations, those same stations up in Eureka, and we're still within that expected accuracy that CSRC publishes. And then lastly, 32 out of 35 stations are under a centimeter in the 3D component, with those same 3D stations being between 1 centimeter and 1.5. Once again, it's lost within the noise of definitely an aerial LiDAR survey and RTK survey. So with that, I know I'm running out of time here. PG&E maintains, just a few more things, PG&E maintains an entire database. We call it our remote sensing catalog of everything we've collected. All the metadata for every epoch, the associated accuracy with all of our LiDAR data, orthoimagery, 3D modeling data is included. It's available to PG&E contractors on any project. And we are ready for NatRef 2022, so I know that was a big talk right before this. PG&E, our geodetic network is ready, our surveyors are ready. It's something I've been harping on them for a long time to get ready for, because it's going to be a big change. And NatRef 2022 is going to be more dynamic, and I know NGS has said that. They're going to publish dynamic portions of it are going to be more dynamic, so our surveyors are going to be ready for that. Well, most of them, I hope, are going to be ready for that coming up here soon. So with that, I'm running out of time. You guys have any questions?
So we have 3 questions for you, Eric.
Oh, sure.
First question, Oakland Hills are full of existing landslides. Is this a problem area for PG&E?
Absolutely, yeah. Oakland Hills is my least favorite place to survey, especially aerial LiDAR surveys. It's a disaster, but we have a great geosciences department. We look at every single tower, we look at potential impacts for them, and we mitigate as needed. Yeah.
Second question, how does change detection work on major earthquakes? For example, the 2019 Ridgewest earthquake.
Yeah, so good point. So change detection is usually, depending on what happens with the earthquake, so Ridgecrest was a good example. Ridgecrest kept moving after the fact. It wasn't just a one slip and then stayed. It had aftershocks and setback, and then it moved again. So typically what PG&E does, or what we did in that case, is we wait for that area to be more stable again. We would then publish that special epic at that point, fly a new for the core stations around that area, where we have a PG&E station in Ridgecrest. We would publish that special epic, refly, reprocess, and then compare using the exact same terminology that I did before to show subsidence, displacement, or whatever we need to in the area.
Last question, can you elaborate more on the cons of the dynamic epics on legal requirements for the PLSS record of surveys?
Yeah, so the Public Resources Code requires that you are on a published epic by NGS or CSRC, and so the only available epics would be 2010, 2017.5, or now 2025.0. And so Public Resources Code requires that. But for us, it's not too big of a deal because we know when those projects are happening, when PG&E needs to file publicly, and we would just readjust our survey to that to satisfy that. But otherwise, yeah, they won't allow, counties won't allow, at least the counties I work with won't allow using your own arbitrary epic for publishing the records of surveys.
Good afternoon, everyone. I'm going to try standing on the side here. So I want to thank the students for having me back here. And the presentation I have for you today, they requested is one I gave in various formats from 2016 to 2019. Automated dam monitoring at East Bay MUD. I did retire from East Bay MUD in 2011. And the last couple of years I've been working part-time at Mark Thomas.
If you could test out the clicker. Yeah.
Okay, we're good to go. All right, so my presentation, automated dam surveying at East Bay MUD. And I'm going to cover basically 2 projects here. The first one is San Pablo seismic improvements. This is back in 2008. I started at East Bay MUD in 2007. And then Pardee and Comanche dams. This is Pardee Dam here on the left. Comanche is this huge area. Here's the main dam and a series of large dikes, essentially dams, damming up this valley. And then this one's San Pablo Dam there. A little bit about San Pablo Dam. Here it is south of El Sobrante in the Bay Area. Originally constructed in 1920. This downstream buttress was added in 1967. New spillway 1973. And then they had a big project and they redid the upstream in 79 and 80 when they dried out the reservoir. So the current project, what they're doing, they cut down this grove of trees. They're going to haul off this buttress stockpile it over here, create drilling platforms to essentially auger in cement down to bedrock, to anchor the dam down to bedrock. So they bring in large drill rigs, drill down to bedrock, pump in cement, back out the drills to auger it in and sets up like cement. The existing monitoring survey, this is old sight lining. You know, surveyors would go up halfway up the hill on either side, and you know, a surveyor would hold a target over each of these monuments on the dam, and you measure upstream, downstream offsets, right? And then they also ran levels to each of these. And so eventually the crew took to run, instead of just sight lining, they'd run RTK all along here, and then inverse the offsets to the upstream, downstream there. But that took a day and a half of work for one survey crew. So as part of that project, okay, maybe it's in another slide, but so I got to East Bay Mud. They're talking about this upcoming project, and they're going to want daily surveys on that during construction, because they're excavating on a dam that's actively impounding water. They need a daily monitoring survey on there, and it took one of my survey crews a day and a half, so it was going to be a lot of labor and staff hours that I really didn't have. So I remember this project that the Metropolitan Water District had in 1999. At the time, it was the largest earth-moving project on the face of the earth, and to come up with the monitoring, to meet the monitoring requirements on that, they came up with an automated survey system, both GPS and total stations, and they worked with the University of New Brunswick on this. Basically, it was a research project, right? So they had custom written software by University of New Brunswick running on industrial computers, right? And so we didn't want a research project. We wanted something that runs on commercial off-the-shelf software, and that, when the server gets upgraded to meet, security upgrades, that the software would be upgraded and run on the new operating system. So anyways, here's the construction monitoring requirements. And this graph is basically how we justify going to an automated monitoring system. If we were to do all that labor during construction, we'd spend quite a lot of dollars, and then we'd go back to the old method of monitoring it twice a year. So twice a year, to me, that's far too minimal there. It would take you a year and a half to figure out if the dam is actually moved, right? With an automated system, you get a survey every single day, and you can tell right away if it's moving. So back to that. So here's our automated system cost, and you look in hindsight, that was a little optimistic. There's some maintenance, the instruments need to be replaced like at least every 10 years, and so on. But it got us what we wanted. It got us our automated monitoring system here. So here's what it looks like. We want to monitor here along the crest of the dam, and then along the rebuilt buttress down here. So we want a lot of prisms, and sighting total stations that can view all of these prisms is a real hard spot. You don't want to get too far away. There was a spot over 1,000 feet away up by the road that could see everything, but then that was really a little too far, and it's also by the road, so it's subject to vandalism there too. So we planned on 2, we ended up with 3. You know, what the heck, we're already doing this. Throw in a 3rd one just to catch a few of these that we couldn't get. We wanted double observations on each of these. As a surveyor, big on redundancy. So double observations, if one total station says that this is moving and the other one doesn't, well then there's a problem. Then you'd start looking at your base station there. So we're putting out a forest of prisms out there on the dam. And we started with these TCA 1201 monitoring instruments. These are servo-driven instruments. Duty cycle, we went with like 4 sets of angles 4 times a day and averaged those into a daily solution. That's actually a pretty heavy duty cycle, especially for these servo-driven instruments. And so here's one where we got some advice from the folks at MWD. Do you leave the total station out in the rain and the elements, or do you, here we're putting it behind glass, right? And so glass, there's some refraction going through glass, and you have to learn to deal with that. We talked to MWD, we used low index of refraction glass, but really you just have to come to some peace of mind about once you put it behind glass, it's a closed system and it's going to be the same from there on out. So we did some monitoring before the shelters went up, and then here after the shelters went up, and then it was turn automated. You know, there's a definite offset before and after, but it's a relative measurement. You're looking for movement, not absolute position. And this one's interesting data. So here's the drill platforms, early construction, and here's the completed project. You know, all this dirt and spoils is hauled back in up on the dam. So there's extra weight here, extra material, and there's some compaction, post-construction compaction. And you can see some artifacts in this data that happens to correspond to when you have to take the instruments in for service once a year. So we take the instrument out, put up a different instrument, and they might be, you know, a couple millimeters in the releveling, and might be a little bit due to the calibration too. So here's one of the big advantages of automated monitoring system. You have an earthquake, well, you can just log in and see if there's a problem out there. You know, EBMUD has a system. If there's an earthquake within so many miles of the facilities, they'll send people out to inspect. You know, are there cracks? Are there damages to the facilities? Well, here you don't have to wait to drive out there. You can log into the system, see if there's been movement. You can turn it on, run it manually, and some of these instruments have cameras in them too. You can actually, you know, look through the camera and see if you can see damage. Next, going on to Comanche and Pardee reservoirs. So this Pardee is a primary water source for East Bay mud. The East Bay built in the late 20s. And then Comanche, this really isn't water supply. This is just to manage the flow downstream from Pardee so they can keep as much water possible in Pardee and maintain their obligations to provide downstream flow for downstream agencies and fish populations. Pardee Dam, and then the spillway over here. So originally the monitoring system setup was just 2 pillars on either side, and you'd set up an instrument and turn angles to each of these stations here. Here's one of the pillars, the RD dam in the background, the other side. And so we just move prisms along, set on this little trivet, pick it up and move it to the next station, make the measurement, and repeat the same from the other side of the dam. And here's what you get twice a year. You get a little data point twice a year, the old manual method. This is precipitation down here. This is a threshold. And this is water level, I believe, yeah. I'm not really going to talk about this much, but we also worked with the USGS with their NetQuakes program. USGS was going to study how seismic waves propagate through large structures here, such as a dam. So we put in, I think, five of these seismic recorders in there. We used an L1 only sensor, and the reason why L1 only, all of the baselines were less than 3 kilometers, let's say, going to a dual frequency would essentially double the cost on equipment. So L1 only sensor to keep the cost in line. And reference stations, at least 2 at each site there. A little bit about this, let's see. Our vendor was the first to come up with these mesh networking radios. So the San Pablo Dam was point-to-point radio sending the data from the total station down to another antenna on site where there was a connection into a T1 line back into the EBMUD business internet. So here, instead of point-to-point radios, where you have a single point of failure, if one goes down, these mesh together and they'll find the next radio. And this is sort of industry standard now. Well, we were the first ones to do this back then. But so the industry is evolving. So the 2 reference stations and then the sensors on the dam, going into fiber optic cable, run it down the face of the dam into the powerhouse down there. And so we use 2.4 gigahertz radios to send the data from here to here, goes down the dam and then into the business internet. So mostly pictures here at this point. We tried to hide these L1 only receivers outside of the dam. This is it's a public traveled road most of the time, right? And it's one-way traffic. EBMUD can shut down the road, but we have to put a notice in the newspaper and let people know so many weeks ahead of time. And so here's our contractor hanging over the side of the dam, installing these, and a little bit about the results. So this is a little over a year's worth of data. Horizontal displacement, vertical displacement. You can see there's some kind of signal to this. And here it's plotted against water surface elevation. And it doesn't really correlate to that kind of movement there. There's no correlation. So the movement is not due to water surface elevation. Here I got a little bit more data, maybe 2 years of data, and plotted against the ambient air temperature, minimum, maximum. And you can see there is some correlation here. So this kind of movement due to thermal expansion. So Comanche, main dam and dikes, huge area, and so this would not lend itself to setting up total stations. It's just too big. These structures are actually very tall. Here again, the main dam. This is dike 1, 2, and then 3 over here. There's little ones 4, 5, and 6 over there. Built by the Bechtel Corporation in the 1960s. They left us with this complicated sight lining procedure. I don't know how you ever got good data out of that, really, but when I got to EBMUD, they were using RTK and then inversing between the endpoints. So the new scheme here, we've got the 2 reference stations. This is on essentially bedrock. It's a conglomerate foundation right here. And then over here, this is definitely in bedrock. And so data will go to, let's see, there's a repeater here. Essentially gets to, everything gets to a antenna tower over here, sent across the lake. Here we have the mesh networking radios, the 2.4 gigahertz backbone here, and then the 900 gigahertz Yagi radio. So the 900 gigahertz will send the data over to here, then the 2.4 gigahertz will send it to the microwave antenna. A little look at the huge structures here, construction photos. They're very tall relative to the surrounding land there. And here's after construction. You can see a little maintenance problem we end up getting here. And here's the problem, is the birds, they love landing on this to look for their next meal, right? And, or they'll take a fish and sit on here and, you know, drop the guts down here. So, here's what we had to do. We had to just glue these bird spikes on the top there. You know, we get the plastic ones, and we did some testing. It doesn't really mess with the data at all. Certainly not as much as a bird sitting on the antenna does. And just construction photos. This was actually a change order. One of the engineers had the bright idea, well, let's just put this over here next to the microwave tower behind the fence, it'll be safer. And no, then you're in the shadow of the microwave tower and you're in the grounding system. And so change order. And here I envisioned like just a, 12-foot pole on there with an antenna on the top. Engineers came back and no, we got the first Fresno reflection coming off the lake to worry about, so we need to get up above a certain elevation to eliminate that reflection. So nice big tall antenna mast there. And here's a repeater. The microwave tower is over the hill here somewhere. There again, change order work. This is very solid. And so while we're out there, a lot of the project was built. We had a $400 million aqueduct project built up there, and there's no cell coverage, so we ended up, setting up base stations every day. So we figured, while we're doing this project, let's just have a 9-foot tall RTK broadcast antenna set up on this microwave tower, and we can just roll up on site, plug our RTK bridge in, and off we go surveying. And so that's it. I think here's what the birds do sitting on the antenna there. Gives you noise. That's all I got.
Okay, so a question. have you ever had any issues with measurements from an enclosure during bad weather?
Yes. Yes. You get a foggy day, you get a damp day, you get a lot of condensation on the window, you get a lot of errors. And even rain on the window, you know, a lot of error, but the fog is worst. Some days it might be sunny out, but since it's damp inside that shed it's all fogged up. And so we did go back and retrofit the sheds with fans in them to clear that out a little bit earlier. Thank you.
Okay, and that's it for the questions that were submitted online. Is there anyone from the audience who has a question?
Yep.
Did you ever find anything? Like, did you ever monitor this and it was super out and you had to alert people and take action, or?
Not yet.
Not yet?
No. That one example I had, there was a moderate earthquake in Berkeley, which is a short distance away from San Pablo Dam, but no movement. Other than that post-construction compaction of the buttress there that I showed, kind of expected movement, but no real unexpected movement. Yep. Still running. San Pablo Dam, the instruments have been replaced twice. It's MS or TM60s now, I believe. Yep, still running to this day. George?
Are the points you're monitoring all on a concrete dam that's ultimately anchored into bedrock, or is it anything to do with an earthen dam?
The Pardee Dam is a concrete gravity dam. Comanche Dam and dikes, those are all earthen structures, and San Pablo Dam earthen structure. The pedestals there are drilled in at least 10 feet into the structure. Rebar cages, they're pretty solid.
So that's even with the earthen dam, you go in 10 feet?
Yeah.
And if you're just sort of looking at the results without a lot of the scientific noise, but you're just looking at some coordinates from one set of measurements a month later, same point, you're just wondering how much it's bouncing around, right? Because errors in measurement. What can you think, like looking back, oh yeah, I remember that one jumping back and forth 400ths or something like that? Or up and down?
No, other than that noise when the birds have landed on it.
Well, it's not all zeros.
Right. Well, what is the noise? Let's go back and maybe look at the scale here in millimeters. So vertically, less than 5 millimeters. Horizontally, 2.5 millimeters or so.
Thank you.
Okay, one in the back.
Hi, Steve.
Yeah.
Good presentation.
Thank you.
And thank you for coming over the years and sharing your experiences with us. My question is about the analysis portion of the project. So can you talk more on the analysis in terms of which software did you use and which points are held fixed, etc.?
Okay. Well, we chose Leica as our primary vendor, and San Pablo Dam, it's Leica Geomatics, and there's two different versions of that. There's the monitor and then the analyzer version. And then at Comanche and Pardee, it was a little different vendor that was called Sensometrics. They've since sold out to Bentley Systems. So they replaced the analyzer with their own custom analyzer software. And then we also had to have custom software written to translate the results into something that can go into a custom in-house automated reporting system to report to help prepare the report to DSOD, the Division of Safety of Dams. Does that cover it? One more in the back.
I was wondering, from the time you started getting bird noise to the time you identified there was bird noise, how long was that?
Well, I mean, we could see that the raptors were landing on the pedestals there even before we installed the antennas there. So it just took us a while to have the vendor come up with a solution. As far as how many months, maybe a couple of months, I don't remember at this point.
Steve?
Yeah.
Is there a different technique that DWR is using or the Corps of Engineers is using to monitor their dams? Or are these just specific to the local agency that you work for? Is there a...
Well, that's a good question. I'm not sure about DWR. You know, it takes a lot to change over the legacy sight lining thing. At EBMUD, we had to have a project, you know, and have the project funded. So the seismic retrofit there on San Pablo Dam, that project was $70 million or something. That, you know, in that, when you have that kind of a budget, the automated monitoring system is kind of minor noise in the budget. You just throw it in there. But if it's just operations trying to get money for that, you know, if you wanted to change all the dams all at once, that's kind of cost prohibitive, really, to do that. Anything else? Eric?
We have a lot of legacy issues inside of PG&E with our dam monitoring as well. Curious, a couple questions. So, typical observation lengths for between Prism and total station, what do you guys typically have? We have, just to preset that, I guess, we have a couple where we're really long baseline lengths across the reservoir. We get a ton of ground refraction due to temperature gradient above the water. So I'm just curious if you guys have run into that. Some of our dams are great, the other ones kind of old school.
Yeah, the vendors will tell you our instruments are, you know, they're excellent out to 1,000 meters, but that's just too far for monitoring. I mean, I would think if you go on 1,000 foot might be a good one on that. And in fact, you know, if we're monitoring, let's say, one of these prisms here, the results from this total station will have very little noise, and then the ones from this one, there'll be considerable noise, more noise to look at it. This is a 1,200 foot long dam, so just the refractive effects along the dam, you know, especially on a hot day, you're going to get a lot of variability. I would not do 1,000 meters, you know, maybe 1,000 foot would be good. All right, thank you, everyone.
There we go. And I hope I got the right logo. Is that the correct one?
Close enough.
Close enough? Okay, so the question I have is, I know what the F stands for. What does the V stand for?
Fresno Valley Central Valley Agriculture.
Okay. Learned something today. Time for me to go home. That's good. Well, I appreciate it being able to be here today. The invitation was sent out. Well, I wouldn't say invitation. He kind of strong-armed me down at Cal Poly, which was fine, Dr. Peterson. But it's great to be here. I actually wish I could have stuck around a little bit longer, because if you haven't paid attention, there's a big snowstorm going back that I've got to try to beat going home tomorrow morning. So we'll see how that goes. But quick introduction to me. Yes, I'm the executive director of the National Society of Professional Surveyors. I've been involved with NSPS been a member since 2000, been involved since 2007 as an Illinois Illinois representative, then was a director, and then when it was going up through the ranks of the officers, I am a licensed surveyor. I am originally from Illinois, licensed surveyor in Illinois and Wisconsin. I fondly like to say that I retired from active work to come do this because this is what I want to do. This is what I like to do. That there's not enough voices out there speaking for the profession, for the students, for the future of surveying. That what little bit we do have, they're just not loud enough. So if there's a way that I could step into a role and amplify that, we want to try to do that. Don't get bogged down by my 84 slides. This could be a 15-minute session, or it could be stretched out to 3 or 4 hours. We'll go through it. No, there's not 84. I'm kidding. I do like to show this because this is one of my proudest moments. This was right after I took the job. I was contacted by the Pennsylvania and the Maryland societies to go out on a Saturday to inventory Mason-Dixon stones. And to be completely honest with you, that was a spiritual occurrence. To be standing there and really seeing these stones that were cut in England, put on a boat, brought over. Mason-Dixon went cutting through the line, setting everything, 260 years ago. I say that because I was sharing this story with a friend of mine. She just happens to be the president of the International Society. She's from England. And I was saying, how proud I was to be able to do this and whatever. And she says, 260 years. You think that's old? How cute. Well, it meant something to me. And that's a significant line. So always like to look back and go, you know what? This is why we survey. It's finding walking in the footsteps, finding where our forefathers have been. So, modern surveyors, this is who we think we are. Got all this equipment, all this technology. Hopefully, students here are learning all of this stuff. That's quite a pile of yellow equipment out there, which is amazing. Very impressed that the facility's been able to do that. But this is who we are. This is who the public thinks we are. I hope they don't think I'm Homer. But this is the perception. This is what we're up against. You all know this. I'm not trying to tell you something you don't know, but this is what we are not fighting against. Because, all right, raise your hand if you do not have one of these. Really? Well, just a smartphone. Smartphone. For some of us, flip phone would be just fine. But we've all got smartphones. As I was saying earlier, where's my Jimmy John's? Where's my Uber? How do I get here? Everything's instantaneous. Everything is instantaneous. And how do we get to this type of a system? Everything's geo-referenced. That's part of where we need to evolve as a society to know more about what geo-referenced data really truly means. And we're at the base of it. We're at that base layer. So examples of some stuff we've had survey-wise. Hey, can I get that survey tomorrow? Even maybe next week? I can wait till next week. Not gonna happen. I only need a simple land survey. Yeah, what's a simple land survey? Most surveyors aren't answering the phone right now. Just because they're too busy working, which is still a problem. The one I like is there any way I can do it myself? Sure, metal detector and shovel and have at it. And the one I really like anymore is there an app I can use to find my corners? Some will say, oh yeah, Onyx and some of these hunting apps, they've got big bright red lines for property lines. Yeah, let's not go there. So when's the last time you've cold called anything for a personal service? I moved from Illinois to offices in Maryland, but I now live in West Virginia. I whisper that because it's kind of embarrassing, but where we live is great, fine. But try to find a doctor, try to find a dentist. And I know, dentist, West Virginia, it's kind of an oxymoron. Try to find an eye doctor, try any of the professional services. If you get a return call, it's crazy. Do they return the calls? No. My wife went through 6 dentists before she got somebody to return a call. And if you get somebody to call you back, what's their time frames? Did you get a range of fees? And are they competitive? How do you know if these fees are competitive if you get one service? And this can go for plumbers, electricians, all these things as well. How do you know they're competitive? And let's not even, we could really get down the road of talking about contractors. We think we're busy in surveying. They're crazy busy doing so much work. So, why does the surveying profession have the reputation that it has? Well, we've provided our services with low profit margins for decades, or actually for generations, because we don't value our services. We haven't. And the opinions of what prices should be have now evolved to where probably your real estate agent or your attorney is going to tell you what that survey should cost. Based on what? What experience, what professional knowledge base do they have to go off of? They don't. But because they are attorneys, real estate agents, we listen to them. And unfortunately, we still do have a little bit of lack of professionalism. But I think the tide's turning. I truly think the tide's turning. And this really kind of goes back to what's all those yellow boxes sitting out there. Used to be when you would buy a piece of equipment, robotic total station was $35,000, GPS, GNSS was 25, 30 grand a unit. We could do our work so much faster. But most owners that were buying this stuff weren't raising their fees in proportion to what their equipment's costing. Well, if it's taking me less time, then I can't charge as much money. Yes, you can. And you should. The equipment is what is allowing you to do that much work that much faster. There's value there. And the public's perception is that now, especially with these things, anybody can do it. I download my county GIS. This is close enough. Kick around. Oh, well, there is an iron rod there. Well, that must be it. Unless it's in the wrong spot. They're not experienced and knowledgeable enough to know that. So rather than continuing with the status quo, we have to step up to the plate as a profession. And I think, like I said, I think the tide is turning. I think, what we're seeing, and this is one thing I love about being involved with NSPS and the student competition. Fresno's coming back, right?
Working on it.
Okay. We hope you do. That's the nice thing about the competition is what we're seeing as far as the students that are coming in now. That Maybe the knowledge isn't there. Maybe the experience isn't there. But the level of professionalism we're seeing at the college team level is a heck of a lot more than what we have seen in the past, and especially with a lot of our practitioners. Because unfortunately, the surveying profession for years has gotten a knock on being bad business people. And for the people that acted that way, they deserved it. But we're raising the awareness of the profession and the professionalism. And programs like this is doing exactly that. And I'm very proud that we're able to do exactly that. So, how do we raise that awareness with the rest of the public? We need to tell the story. Who are we? What are we doing? What is our value? We need to be able to tell that story. And that's what's going to draw people in. That's what's going to allow them to understand, I'm not the guy standing on the side of the road taking pictures. A surveyor is not somebody standing in the mall with a clipboard. We are doing this for the betterment of the public. And all of this data, especially now that we're coming into such a digital age, it's very important that it's right. Because everybody's going to take advantage of what we're doing going forward with everything digital. Let's see. Strategically, that's part of what NSPS is trying to do, is we have 15,000 members across the country, licensed members. We know that because that's what the states tell us when we were in our membership agreements. We need to recognize that all of the people within the profession, the technicians, from SITs down, anybody involved in that work is part of the profession, period. It isn't just about the licensed professionals. You know, and the bad thing is of those 15,000, overall there's 35,000 licensed professionals in the US. So even within our membership, the ones that we can communicate, we can only get to 40% of them. There's another 60% out there doing the work that we're trying to reach out to try to influence, to try to get them to be a better surveyor. Because that's what's going to help us in our longevity. By increasing the communication with the public and helping them understand the impact of surveying on the world, we can raise the professional profile of the surveyor. And it's not even just land surveying, boundary surveying. It's all of the things that is encompassed in the surveying world now. You know, that's one thing that, I wake up every morning and I look at the guy in the mirror and I can't believe who's looking back at me. Because, you know, I still want to be that 20-year-old kid that my dad, I was 16, my dad was a surveyor, called me up, first day of summer vacation, between my sophomore and junior years of high school. Called up, now of course, if you need to go look, for some of you, go back and look at this up in Google, figure it out. I had to go out to the kitchen because that's where the phone was, on a cord, and my dad says, get your rear end at this location, I need some help. The rodman he had worked for him decided, hey, you know what, he's not coming to work today, he's gonna move away and chase his girlfriend somewhere. So I got a trial by fire to get in. The funny thing is, and the reason I bring that up, this was a long time ago, even at that point in time, our focus as surveyors was very narrow. It was boundary surveys, topographic surveys, had a little bit of data collection, but not a lot. Boy, my hand got tired from writing all those notes. Some leveling, I mean, we were very, very narrowly focused. Fast forward to today, and I haven't anybody challenged me on this yet, but feel free to do this. But show me a profession other than the medical field that has been transformed more by technology than the surveying field. That it's widened so much. I mean, there used to be things that, you know, only pilots and photogrammetrists did. Well, I can buy a drone now. There were only things that hydrographers did. I can buy an autonomous boat now. All the LiDAR scanners, all of this remote sensing work, it's all specialized now. So like the medical field, I will say, and I've had a few people cringe at this, but think of the surveying profession like the medical field. We all can't be doctors. We all can't be LSs, because there are specializations down through here. Now, I'm hoping everybody in this program here, there's a reason you're here. You're trying to get there. You're trying to get to the pinnacle of your profession, become a licensed surveyor. I want you to succeed, and there's a lot of people counting on you to succeed. But the profession still needs a lot more people. And that's part of what this outreach is doing, and all of the things that we're doing surveying-wise. I usually do a little poll of business owners when I get in some of these places and say, if you had the choice between a good solid LS or somebody that's very, very good either in the field as a tech, with remote sensing, with UAVs, with boats, with whatever, or very, very good at CAD and seeing things in 3D, which would you hire? 9 out of 10 say they'll take the tech. But that doesn't mean that the surveyor is not important. Yes, they are. The licensed surveyor is still important, but we've got such a broad range to fill in. We need to do that. We got to raise the profile of the professional surveyor. Because to me, a professional surveyor and professional surveying is not just the surveyor, it's everybody in that office, everybody on that team, even down to the administrative assistant that's typing up legal descriptions, which unfortunately with OCR and AI now, that's going to go by the wayside. But it's a tool. We won't go down that rabbit hole. The goals of our practice should be to elevate the value and respect of the profession. And that's what I hope that we're trying to do, is trying to be a little more respected by the public. Because we may not be seen as a lifesaver, but hand a bad survey to a civil engineer or to a GIS professional and see what kind of mess it causes. Doing good work, doing correct work is critical. We simply need to become better storytellers. So what about social media? And this is what I like about being on a college campus. Where do we get our information these days? I didn't see a bunch of newspaper machines out here. We're not watching network news. A lot of it's coming through social media. It's coming through this. How can we leverage that for the surveying profession? That's the important thing. And how do we raise the awareness of the profession? Well, we got old school communication. It worked for the time. But now we gotta go out social media wise. One thing I'm very proud of in the time that I've been here as executive director, last year, and this has been through some significant partnerships and financial support, including Trimble, we were able to hire a marketing team last year. I was telling somebody earlier, Elaine Ball out of England. She started a little thing, hopefully you guys are aware of it, called Get Kids Into Survey. With her, we've distributed over 80,000 posters over the last, I guess it's been 7 years now. Getting these posters into the professionals' hands, getting them into the kids' hands, just another way to explain what we do. Well, we hired her because she's a marketing person. She's actually the daughter of a surveyor, and tell you what, she is the best person I've ever met to market surveying, and I'm glad we hired her. Because she's shown us things that we've expanded our social media footprint in a lot of ways. And it's driving a lot of people back through our website. So the content on the website has to be good. It's forced us to reevaluate some of those things, besides just a social media post. We also have another website called beasurveyor.com. This was originally started in North Carolina. They kind of dabbled with it. They ended up giving it to us, saying you could probably make more with this than we can. We got involved with NCSS. They funded a revamp of this. If you need anything, questions answered from very, very basic through what surveyors do and why you may need a survey, this is a great site. All the schools are listed in here. A lot of great information. Once again, if the public needs to know what surveying is doing, hopefully when they Google, or are we doing ChatGPT now? Either way, which we'll get into that in a second. We want it to be driven towards us and good information. Make sure you've got it. Another one we want to talk about is CST, and I know Dr. Peterson wanted to talk about this a little bit today and how important the CST program is. Depending on who you talk to in the profession, they either love it or they hate it. It's not worth anything, or I'm so glad my staff has embraced it. Because it's a way, especially somebody working towards licensure, it's a way to gauge what you know. I've seen enough resumes in my career, through my wonderful years of middle management, that I've seen the resumes. I've worked at 6 companies in 8 years, and I know all of this equipment. Great. Hire them. After 2 weeks, you realize they don't know nothing. Or, excuse me, they don't know anything. My wife just screamed at me for saying that. Don't know nothing. They don't know anything. They may have worked on a crew that turned on a static LiDAR at one time, or they watched somebody fly a UAV, but they don't know how to do it. But they were in the vicinity, they put it on their resume. CST is a great tool for evaluating that talent at various levels, field and office, and really helps prep for anything you want to do beyond that. TrigStar is another one, and California is, I'm going to say blessed. For those that know Sherry Talgus? Always trying to remember how to say her name. She is a spitfire on pushing TrigStar, because this is a good opportunity, and this is where people get, once again, surveyors either love it or hate it. It isn't about the competition itself, because the people that when you're doing this Trig Star competition at the state level and the national level, the people, the young students that win this competition, they were never going to survey. They're going to MIT. They're going somewhere else. However, this is a great opportunity for a surveyor to be able to go in, talk to a math class, talk to a physics class, and say, oh, you know all that trig you're learning, trig, algebra, geometry, all that stuff? Yeah, you do use it. Even though my wife says we don't. Something we're putting together also at NSPS is a dashboard. I think Esri is a pretty big company here in California. We're putting together a dashboard that anybody needs anything to know about surveying within the United States, they're going to be able to go here. Licensing requirements, licensing number of credits, the curriculum, licensing board, anything you're going to want to know about a state will be here. We're throwing more and more information on here. We're trying to map where all the surveyors are at. What's funny is, in a lot of these places, we call them survey deserts, that we're getting calls from small municipalities that say, we don't have a surveyor in our town. The closest one's an hour and a half away, and that's with a big firm. What can we do to attract a surveyor to our area? Because we need those services. No difference than pulling in a town doctor. We've got a little podcast that's going on. In fact, we just released episode, actually 219. Gentleman you may be aware of, Gary Kent. We've got some new land title survey standards coming out. This week was the first in what's going to be a series with Gary talking about the new standards. As always, Gary's a great and fascinating guy to talk to. Check it out. We're actually also doing this on video now, so we got it on a YouTube channel. And any Cal Poly people in the room? No. We were down there in September, and I was able to sit down with the Cal Poly students, and we did a podcast. And it's great to hear the perspective of the students. I know I'm short on times, but we need to do that with the students here as well. We need to hear your story. Young Surveyor Network, we need to keep promoting that. California's done a great job promoting the Young Surveyors Network. We exhibit at the American School Counselors pretty much every year. It was in Long Beach one year. Teachers and counselors have no idea what surveying is, but they're starting to learn. So what lies ahead? Well, promotion. Global Surveyors Day, National Surveyors Week, 3rd week of March. Do what you can. Get out there to promote. Because this is not the future of surveying. 3 Texas surveyors, good friends of mine, all good guys, great surveyors. That's not the future. Including the short guy in the red. This is the future. And I included the Cal Poly team, because that's who I have. But this is all the future. One thing I do always want to try to point out, this was actually 2018, so it's been a few years, but this group of women right here, it was part of the Young Surveyors International that were meeting with us. At least 6 of those young ladies, as of right now, are sole proprietors in their own business, which is amazing. So let's plant some trees. When was the best time to plant a tree? 20 years ago. When's the next best time? Right now. We need to plant some trees. And I'm glad this program here is flourishing as much as they have. Otherwise, I don't think we'd see all those yellow boxes out there. You're doing something right, which is great. But we need to keep pressing. I always leave this as my last one because this is the result of either a bad survey or no survey. And this is actually a government agency in Ohio that decided they didn't need a survey. They knew where the line was. Till the neighboring adjacent owners had it surveyed, and this was the result. That's bad PR for everybody involved because they didn't value the surveyor. That's why we need to be more upfront. So, that is my contact information. That is my cell phone. Text me and I will get back to you. That's my job. And I'm here to promote for everyone because it's important. It is important. And in these interesting times we live in, and I say that because we've got to stay out in front of it or we're going to get deregulated, because if anybody can survey, then why do we need licenses? Not everybody can. I don't want anybody else picking up a scalpel than somebody that's qualified. I also don't want anybody collecting data or determining boundaries without being qualified. But let me know how I can help. And with that, I'm going to call up Dr. Peterson, and since I've taken up a majority of this time, to talk about stuff and to answer your questions.
We have a few questions. I believe they're for you. So our first one is, has NSPS ever considered creating a branch of mediators and arbitrators, specifically for land boundary issues, similar to what the Society of Royal Chartered Surveyors do in England?
Funny you should mention that. I actually have an unofficial appointment with RICS, R-I-C-S, in June. I was invited over there to meet with a couple of their surveyors to trade some stories, trade some standards. And this is one of the things that we want to talk about, that we want to pursue, because another part of what we're starting, we're going to be unleashing later this year, is a speakers academy. Gary Kent is heading it up with a few others, putting some programming together where we can build the next level of speakers. Because Gary's only going to be around so long, Dave Doyle's only going to be around so long, a lot of the others. In addition to that, and the reason I bring that up is, beyond that, we want to do a business academy about the business of surveying and how we head off that type of mediation, how we work out our problems before they go to the licensing board. So, to be continued. Good question. That's the first time anybody's brought it up other than the back of my mind, so I'm glad to hear somebody else is thinking that.
Then we can do one more question. What can we do to prevent AI from being prevalent in areas such as land descriptions?
AI. What is not affected by AI right now? Let's see, it was all over dimensions, it was all over the Esri UC, everything you read is AI. I see it, and I'm hoping more people see it as a tool. It can be a great tool, but it will not replace the judgment of the person, of the surveyor. There's always going to be technology that's going to help us write surveys, create legal descriptions. What I'm hoping I don't see in the near future is an opportunity for AI. You feed it all these plats, you feed it all these legal descriptions, and hit go. Oh, and by the way, throw in a few field locations of some monuments you found. Hit go and it spits out a boundary solution. We don't need more people that just work on the geometry. There's more to it. I had instilled in me from an early age, honor the monument. Unless you find other evidence that's absolutely wrong, honor the monument as best you can. But if all of this field collection, all of these legal descriptions don't fit the math, that's where I fear some people will go. Because let's also be honest, it's also a business decision at times with billable hours, time frames, getting it done. Are we going to be lured into pressing that button and saying, oh, I need an answer. I can't sit over this thing that much longer. I need somebody else to make that decision. So we're going to continue to follow it. We're going to continue to monitor as much as we can. One other thing that I'm heavily invested in, I'm the chair of Commission number 1 for FIG, International Federation of Surveyors. And it's professional standards, and I also chair a subgroup called professional ethics. We got to be careful by throwing all this stuff into AI. What are we turning our back on with your professional ethics if a machine is taking all of this data and the machine, based upon what you give it, it makes the decision? Unfortunately, my opinion is that that's the professional being negligent. But we'll see where that goes. So with that, I didn't cut Scott completely off, hopefully.
Not at all. We're good.
Sweet, thank you. Appreciate it.
For one, it's a privilege to have Tim here with us. It's quite a bit of a travel to get him all the way out here, and as much traveling as he does to get around. And we're grateful to be able to have him here down at our conference. So thank you, Tim. One thing I want to do is just let you know, my focus for this little portion of it, yes, is through NSPS, but it comes through the NSPS CST, the Certified Survey Technician. I know everybody gets up here and says, hey, this is who I am, this is what it is. Well, yeah, I'm one of the coordinators for the CST. So why then I get to get up here and promote it? And I am one of those ones. I think I do. I love the program. There's so many out there that as an educator, as Fresno State, we're like, hey, we are a 4-year program. We offer a degree. We should get, everybody should take the FS, get their LSIT here in California, then they should go on and get the professional license as a land surveyor. Absolutely, I think that is one phenomenal path. The second thing that we have, though, is we have other schools. We have Reedley College. We have the Fresno City Community College as well that are offering classes and everything else that it also is directing things as a, what happens if you don't want to be a licensed land surveyor? What happens if you don't want to do that? I mean, I don't want to make anybody raise their hands or whatever to say who wants to do what, but what I'm suggesting is that there are paths. There's different paths for everybody as to what they want to do. So what I learned a long time ago, and I'm grateful for my wife for this, is that she told me no matter what, she'll support me whatever I do. And I'm very grateful for that. That's where and how I got to here, where I am now. But she told me though, no matter what you choose, she wanted me to go as far as I could in that path, whatever that is. So if you come here and you go through a 4-year degree, come to Fresno State, and you get your bachelor's degree, I want you to go as far as you can. I want you to get your license. I want you to go as far as you can. But then there's others though that hey, you know what? I love working in the field. I love working in the office. I love whatever those differences may be. But I'm just not one that wants to take on having a license. There are some that are out there, and that's absolutely fine. And you are absolutely needed in that same fashion as there are other licensed land surveyors. We always get up here, and I'm one of those that says, hey, The average land surveyor is X amount of years old. Y'all are old. Time to retire, get out of here, right? No, that's, but it is, it's getting up there for what the licensed land surveyor is. We need more, absolutely. But we also need more certified technicians. We need people that when you send them out in the field, man, they know what they're doing and they are rocking it out there. You trust them, you believe in them, you do all those sorts of things. I was talking to someone just right before here that said, yeah, I'm tired of hiring people that are just coming off the streets. And we have to train them, we have to do all these sorts of things, and man, does it get tough to know, can you trust that person out there? Well, lo and behold, there's just several different programs, different paths for everybody that's involved. One that is not as popular out here at the moment is the CST. Back east, you'll find it is a lot more popular, but out here it isn't as popular, which is fine. But we can change that if we want. And that's why I presented to you to say, hey, is this something we really want to go further with? You as industry professionals, you as owners, you as business owners, or those who are out there seeking jobs and everything, well, what do? You have to go out there and say, this is how awesome I am. You put out your resume every time you do your RFQ, you're like, hey, this is what I am. I have this many licenses on it. I have this many certified federal surveyors on it. I have this and this and this, and this is my staff. And then I have survey technician, done, that's it. If that's even on there, and you get points for it. Well, within the CST, there are different levels then that you can actually go through. There's CST 1, 2, 3, 4, both for the field and for the office. Let me get it right. It's a little slow. That's how I am. There it is. All right, so there's what it is. You have several different levels that you can go through. Am I out of the way? We'll do it this way. How's that? Okay, there's several different levels that you'll be able to go through. That means back east, that's part of their preparation. That's part of the thing. This is what I have. And so they're certified at different levels. Now, is it a license and a stamp? No, it's not. But it is a path forward for those who are a technician that want to continue to move forward and do really, really, really good work. And so it's for you as an owner then to be able to hire somebody like, hey, yeah, I want to push you through and really get you qualified. And it even, honestly, what it does is it even prepares you then for the FS, even more so, to be able to come licensed if it comes to it later on down the line. But there's 2 different tracks right there, 4 different exams for each of the tracks that you go from the field side as well as the office side, so depending on what you have. We want to be able to help you as a technician to become more qualified, yes, absolutely. Have that education behind you, have those certifications behind you to do this and be more. And then you as an owner, you can be proud of those individuals that are doing this, that are moving and pushing forward, taking different exams. Now at the moment, yes, there aren't any licenses, there's no stamps that goes along with it. It's how you use it. So you can use that as a push to help you to, here's hiring standards. After a year and you get this, then, here's 10-cent raise. I hope it's more than that. But that's what you can use it as. But then you can have a lot more confidence in those who you're pushing out there as technicians to know that they're doing good work. Not that you don't know them already, but don't you also want them to go as far as you can? Or do you just take that technician, use them, abuse them, and push them away later on down the side and say, okay, we're done with you. We'll get somebody else that's cheaper now. I hope not. It's your business, you do what you want. But all I'm saying is from an education perspective, man, do we need more of both. We need phenomenal technicians, we need phenomenal licenses. And so coming through a 4-year program, coming through a 2-year associate program, whatever it may be, this is a phenomenal, phenomenal path. And so what that means is, yeah, you take exams, they cost money, you study for it, you do all those things, but it creates now, when they come to you and say, and I know how it is right now, we tell all the students, hey, we want you to have your LSIT. We want you to have passed the fundamental surveying exam through NCWES, and we want you then to get your LSIT in California. And that means a lot, doesn't it? As an owner, you want that, you're like, yes, absolutely, I know you're good. Okay, but what about those who don't go that path? What about those who aren't doing that or are ready for it? Well, how about if they came this way and said, hey, you know what though? I'm a CST2 field. I'm a CST level 3 on the office. That should give you a little bit more confidence in that individual that's also seeking for a position in your company to be able to help you, benefit you in certain different ways. Like I said, it's not a commonplace here in California, but we have companies that are doing it more. There's some companies that are more national that people here in California are doing it. It's phenomenal. It really is. And I would hope that you as an individual, you as an owner, you as in the profession, that you look for anything and everything you can to be better. And if that means an extra certification, you know what? Maybe somebody looks at that and says, who cares? But to you, that should mean something. That you went above and beyond even further to what the rest of the nation is actually looking at and doing. So let's say you end up leaving California. Hey, this is awesome. You've got something more and more behind you that's gonna be able to help you out. Okay. So my position is to encourage to do this. Encourage those to apply for it, go for it, take those exams. As soon as you're licensed, sorry, I mean, you can still do part of it. It's not for you as a license, but it is for all those that are still technician level, those that are RLSITs, those that are still looking to get their license, want more experience, whatever it may be. Heck, anything along those lines should push it better to make those, I call them students, but make those individuals within your own business or company awesome. And that's our hope. That's my hope as an educator. It's my hope as anything, that I just want to see you guys do great. I want to see just in each one of our students go out there. And I look at some and I'm like, yeah, I don't know if you're licensed material. Just kidding, guys. But I don't say that in a bad way. I say that as some just really, really love it. I know some people that absolutely love the field only. They hate the office. Absolutely hate it. Great. That's your path. That is absolutely your path and you're happy with it. Why can't we make it easy for everybody to do this? So you as an owner, I'd hope that you look at it and be like, I want my business to be good. I want somebody else to say, I want to be part of that business. But hey, I want to, and I know it sounds bad as we're here together, we're all supporting one another, but as soon as we leave here, aren't we competitors? I know you are. I know you're like, oh, that dirtbag company over there, right? They're always taking my business. They're always doing this. Well, okay, let's push something a little bit further. What can you do to be better? What can you do to look better on your resume as a business to do so? And that's by doing additional little things like this. Not only as a license, but as your technicians can do these things as well. So, that being said, I just want to push it. I want to say yes, absolutely. We also have an opportunity for those who are taking the exams, that you, every one of you, can be a proctor for these exams. The way you can proctor it is like these exams are not just going to a testing center. It costs a lot of money to do it that way. So what do? We ask the individuals to find a proctor. So you can be a proctor. We can be a proctor here at the university. We can do big, large groups, small groups, whatever it is. But that allows you then to give also back to the profession to help out and do those things. And I know a few of you that are out here are proctors. And if you call me and say, hey, I need somebody that is a proctor, or we need to help find somebody, then that's part of my role, my responsibility with the NSPS on that side. So anyways, just want to throw a shout out to this. Make sure that look into it. Make it a part of your business. And in the future, the goal is this, is we would start conversation here, but how can we get this into something even further that states, like when you do go to some of these large, bidding processes, that's actually part of your point system. I have X amount of CS2 level 3, I have X amount of CS2 level 1, whatever it is, we like to be able to implement it in there. And that way you can then also push for those additional things. But again, that's a process. We start the conversation now, get it in your head of is that what we want? Do we want that as a profession here in California? I hope so. But if not, then we'll still push it, but not at that degree. But if there's support for it, absolutely we want to do that. And that I think definitely will help you guys out even better. So anyways, to be here. Thank you for taking a minute to listen to me for a minute. You'll hear me much more throughout the rest of the conference. You'll hear me tonight. You'll hear me everywhere to give thanks for everything that's happening here in this program. From those that are offering, you showing up. My goal for you, here's a goal, is next year when you come, bring another pal with you. Make them pay too, but bring somebody else with you. Okay, we want to make this even bigger and better. It's already great. But I envision like, man, I want to, like every seat full. And maybe it's just me that I'm in here speaking, that's probably why it's not full. But I think we can do that as we continue to grow this and grow this. We're grateful for all of our sponsors, our partnerships, our everything. Trimble, CSDS are the big ones that we're promoting right now, yes. Because why? You look out there, it's yellower than yellow. And that's great. I want to make sure and understand too, in the past we had other companies, we had Leica that was helping to sponsor us, and that was phenomenal. It was a stepstone to get to where we are now. We don't look at it bad at all, but we have phenomenal things that the program here is flourishing. It is going, it's moving forward because of you guys. I'm grateful for that, so thank you. That's all I got, so thank you very much. Any questions?
Okay, so Dr. Peterson, we have a few questions. Will Fresno State have a CST preparation program?
So wonderful question. I like to say yes. I like to say that we want to involve this more in the curriculum and the program that we have. But until then, one of us, somebody, needs to start something that we can create a little program that we can do that. There's a lot of material that we have that we're actually preparing that are online for study materials, for presentation materials, that would allow us to be able to run through it and help prepare your technicians for it, to be able to take those certain exams. So I don't have a great answer just yet, but will they? I'm going to say yes. Yeah, we like it. Okay, what else you got?
Does an individual have to start at level 1 if they have enough years of experience for a higher level?
No. So if there is a certain amount of experience that's already in there, it can be looked at, and then you can start it. You can start at different levels. But in the reality, if you ask me, it's easy just as well just to take each one of those and push all the way through it. You hate to be like, oh, I've got all this experience and you can't even pass level 1. That looks bad. But anyways, there's definitely processes in there. And if you have any questions, so I am the coordinator for California, or we also have an NSPS liaison as well, so you can go through Tim and ask him who that is. But if you have those questions, those specific ones, call me and say, hey, this is where I'm at. And then I'll bring that to the rest of the board and say, hey, what do you guys think? And then does this work? Does it not work? Whatever it is, we can tell you exactly how to get through there and push through it. So.
Does NSPS have a federally approved apprenticeship program?
Tim? No. No. Whoever asked that, no. Should there be? Great. It would be really, really awesome, actually. And I think that's kind of where the CST is trying to get to. But this started years ago, just more of a grassroots thing. How can we help the technician level? And it's really, really grown, where we're offering a massive amount of tests every year for these technicians to be able to go through. But that's what I'm saying is it's going to take NSPS to push it through each of the states and even up to the national side to say, here's what we want. You're going to see changes at NCWS that are wanting to transition between, okay, are we licensing as a boundary surveyor versus construction? Are we pulling out the PLSS now out of some of those exams and only certifying in certain states? So there's a lot of things that are moving and getting there. But therein lies then, do we have enough support that lies behind there to make that and push for that? And part of what Tim did and talked about is the promotion of us, of who we are as a profession and industry. Yeah, we're still looked upon as like, we don't know who you are. I tell the story all the time. I've been doing this now for 20 years, 24, 25 years. And every time you ask my dad, so what does Scott do? Oh, he's in geomatics, or I don't know what it is. He can't still say the doggone word. So, go figure, right? And so if you and my dad has to ask me every time, and he doesn't have Alzheimer's, that's what's sad. He must not love me. But that's what it is. So whatever it takes to get to that point, yeah, we can promote it and change it and make something happen. But great questions. But if we have the support to do that, then yeah, we need some champions. We need you guys to also want to be able to do this. Tim can't do it on his own. Although he should, but he can't do it on his own. So That's all we got. Anything else?
Would you say the CST field track is equivalent to Union Pathway?
It's better than Union Pathway. Those who teach within the union, and forgive me for anybody that's in the union right now or anything, but you're being taught by...
Grade checkers.
Who?
Grade checkers.
Grade checkers, yes. I was going to say something else, but thank you, that's a better word to say it. You're not being taught really by those who understand what's needed out there. So the CST is a much better path, and can we get this into the union for the union to accept this as a pathway as well? Man, that would be phenomenal. But there again, there's that another step right there.
Okay, and then one last question. Where is Fresno State at with offering an online degree?
We are in Fresno. Trying to offer, oh, that's not what you want, okay. Where are we trying to get it online? We, man, is it a process with university politics. So I apologize, I want it. We're going that direction. As our advisory board meets and we talk about, hey, what's next to make those steps, we're trying to get there. There are the biggest concern is going to be the following, and that's then where it's going to actually have to rely on you guys as owners, as individuals, as licenses, is when we do lab work. There's two options. One is to have everybody travel up once a month or twice a month to come and do labs on Saturdays for online stuff, or we rely on you as industry to sign off that they are doing the lab work. So if I have a lab that says they need to do a resection and then do some construction stakes, whatever, to prove that they can do it, I rely on you. So do you want to take that on? I see some heads absolutely not, and some are like, yeah, let's do it. That's the hard part. Because we are an accredited program, I've got to make sure that how we do that analysis is making that it's still legit. I can't have one of you being like, oh, you're my bud, I'll just sign off on it, it's okay. There's got to be some checks and balances that go in there, and until industry is really alongside with that to say that we're willing to do that, man, we can really jump on. But that's the biggest hurdle right now. And that when you talk to other schools that have online programs like that, that's the hurdle. They talk about it, they do it, and they're doing it. There are some online programs, but how do we fix that issue right there? And really requires you as an owner or a license to be willing to sign off on somebody's work to do that. So if everybody raises their hand and says, yes, we are, and we want to do it, sweet. I can bring that to the university and say, all right, we're going to make this more online, and we're going to make it dual, so we're still in person, but also have a component where you can learn online, because it'll increase the base that we have for students, and being taught by phenomenal, like the best of the best professors here at Fresno State. Yeah, I know, right? Come on. Yeah, that's right. Come on, students. You guys gotta, they're like so full of crap. So that's where we are with that just yet. But great questions, and we're moving in good directions. You guys got to understand, like, where we've come in the last 10 years, we are moving forward and growing because of you, because of this conference, your support, industry, everything. I wish it was faster, but we're getting there, so. Bad, good answer, I don't know, but that's all I got.
All right, thank you, Dr. Peterson. If we could all give him a round of applause.
The 1980s did amend their law to include what's called an 8765 corner record, which is basically a survey light, boundary survey. It's quite different from the traditional corner record, but still goes on the same form. This is an example of a corner record from Alameda County. It's the second corner record that was recorded. This was 1974. There's a brief written description. The second sheet of this would have a sketch of what the corner record, or what the corner looked like, and ties to any nearby witness monuments or bearing trees. In 2014, we've got a different
Slightly different form. You can see we've got coordinates added here, and there's a provision for NAD 83 or NAD 27. The NAD 83 epoch is added. In this case, the corner record says it's a 2014.25 epoch. But the corner record is pretty similar. You've got a slightly different recording information here, book and page. The document number is still the same, CR. So we're up to 6,406 corner records since 1974. And then in 2025, this is, like the most recent corner record we're processing. Coordinates are still in here. You've got some new stuff though down here. Complies with Public Resources Code 8800, 8890. So there's some new requirements for coordinates. And one of the things that I'm investigating right now is it possible to put coordinates on a corner record and still comply with the PRC? I'm not completely sure about that. It's difficult, it's going to be difficult to put all the information you would need for coordinates, for California coordinate system coordinates on a corner record, but it is still here.
So you don't think that's just basically making a statement that I follow the public resources codes and numbers that I'm putting up there, which sort of making the claim that yes, I do follow the law.
So Dave, I'm going to give you the microphone so everybody can hear your question.
Okay, so the way that I interpret those two checkboxes is that it's asking me if I follow the law.
No, it's okay, because I'm gonna walk around. That way I can talk.
It's asking me if I follow the law. Obviously, I'm not going to have room on a corner record to show my control diagram and all that kind of stuff, but that's the way I interpret it.
Yeah, so I get what you're saying, Dave. So my response is, if the PRC says you have to show ties to 2 independent core stations on your survey, how do you show that on a corner record if you've only got, an 8.5 by 11 piece of paper? So, yeah, you could say I follow the law, but where is it that you've written that stuff down that says is required? Doesn't that need to be on the corner record? That's my question. Possibly so. And so if any of you guys have thoughts or opinions about this, I'd love to hear it today.
Is there multiple pages you can use for a corner record? I'm curious.
No, they're limited to 2 pages
only. I
only.
never did multiple pages on this, so you're right. You're limited to 1 page.
Yeah.
Interesting.
Yeah. So this next slide is kind of just, we've kind of covered the first topic, explain what a corner record is, kind of the history in California of corner records. Now we're talking about the process of going through reviewing, examining, and recording a corner record and comparing the paper process versus the electronic process. So over here on the left side, we've got kind of weeks and days, and then over on the electronic side, we go to days and hours. So clearly there's kind of an order of magnitude shift of the process if we go to electronic. We start with a preliminary paper version of the corner record that would be submitted to a county surveyor for review in the typical process. Paper copies would be reviewed or approved. Communications were always done by mail, old days. Then the applicant would submit a signed, still paper copy of the corner record for recording. The county surveyor would again sign off on the paper copy. That would get scanned, it would get indexed, and it would get filed into a set of paper binders. I'll show you a picture of ours in Alameda County. On the electronic side, we can take an email copy in PDF format as the initial submittal. So that saves a bunch of time and printing. We review it with a Bluebeam, a PDF editor called Bluebeam software, but that's not specific to our process, it's just what we use. All the communications back and forth are done by email, so there's no waiting on the postal mail. The applicant signs the PDF electronically. I'm going to get into the signature process of this. That's probably maybe what most people would have questions about. County surveyor would sign it electronically. We put it into a computerized index. It doesn't go into a paper index, and we store it in a database.
Then for Alameda County, that's served out to the public through a web portal where you can search for corner records or records of survey. So is it legal to do this electronically? Well, yes. The answer is yes, it is. Here's why. So under the regulations that the board promulgates, they've provided this provision for doing it electronically. Corner record may be submitted in an electronic medium if the county surveyor has a system to provide for the submittal, archiving, and distribution to the public in an electronic or hard copy format. So in Alameda County, we provide for electronic distribution to the public. So we can accept electronic corner records for submittal. Traditionally, though, the corner records were fastened into a suitable book. And again, that was back to that old 8773 law. That was the original GLO type corner record process. So what's the difference between electronic and digital signatures? I've talked to a couple of county surveyors that are trying to do this, and one of the things that I hear from them that hangs up the whole process is this problem of dealing with digital signatures. So digital signatures are kind of a subset of electronic signatures, and you've probably seen digital signatures. So it would be the type of thing where you have to create a user profile and you create an encryption key. If you've used DocuSign, that's a digital signature. The problem with digital signatures is because they rely on cryptography, they're intended to invalidate themselves if the document is altered in any way. So the problem for corner records in any kind of recording process is we need it to be submitted to us as the recorder, then we need to go through our processes and get it into our database. Well, when we manipulate that data, it would invalidate the signatures. So what some people have said is, well, we'll do the digital signatures and then we'll print the paper or we'll print to PDF and we'll use the print of the digital signature as like the recorded document. And that's okay, but that is no better than just doing an electronic signature because now you've lost that cryptography sort of advantage of a digital signature. So in Alameda County, we're using what's called electronic signature. And electronic signatures are sort of understood and allowed under the law in California, under this section of the Civil Code 1633. I think I've already said this. The key to this Uniform Electronic Transactions Act is that the intent, attribution, and integrity of the signature are somehow able to be confirmed. So we'll talk about that next. So intent, the intent of the signer to put his mark or his stamp or her stamp has to be part of your process. So for us, intent is documented because we have a chain of communications with the applicant, right? The applicant has to sort of register and tell us they're a licensed surveyor, they have a business, they send us a check. So there's like a history of information that goes along with a corner record. So that is part of our process. We keep and archive all that information. That demonstrates intent that this corner record that eventually will be recorded is meant to be signed by the surveyor that's submitting it. So this is kind of a screenshot of how we archive correspondence. So for instance, we've got email that comes from a surveyor. We put that into our electronic file folders, and then that's archived and backed up, by our IT department. Probably at some point we're going to have to make that more formal and figure out a way to preserve that for historical purposes better than what we currently do. But that's our current process. Attribution. So we want the signature to belong to the signer. And this is a little bit different than intent. So we have kind of this history that goes with the surveyor. Now We do have potentially a problem here where, we get communications from an office staff. It's not from the surveyor directly. That could be a little bit of a problem because the office staff is not the licensed surveyor, and they're not purporting to be the surveyor, and yet they're submitting things to us. So we look at that and we try to make sure that the surveyor is involved in those communications. And if I see a situation where we're communicating with a non-licensed person, we raise that issue and say, we need to make sure the surveyor knows about this. And we did have recently a tentative map come in, stamped by a surveyor. He said on it that he didn't do the topographic survey and he was disclaiming any responsibility for it. And I sent it back to our planners and said, you've got to mark it incomplete. That doesn't work. And then I talked to the surveyor, and the surveyor said, I don't even recognize that map. I don't know who prepared that map. So that could be a situation where, something is coming in under that surveyor's name, not attributable to him. So in our case, this is kind of an example of the evidence we collect. We have a database with surveyors' names and address. I've given you kind of my name and address as an example down here. We have checks that come in from the surveyor, has their name on it, has their signature down here. Those types of things kind of help us with this attribution. And then integrity. So we want the chain of custody sort of to demonstrate that the document is unaltered after we receive it. So in this case, we have the chain, in our chain of custody, we've got the communications and the emails with attachments, so we could go back to an original document and show, if we needed to, that the recorded document matched that original email submittal. We also have standards of practice where we try to make sure that if there are any changes needed on a corner record, we would document the communication with the surveyor saying, like, we would like to see a change, and then have the surveyor affirmatively respond, yes, we will make the change, or we would like you to make a change, so that we can preserve this integrity of the documents. So indexing and serving these out, this is the last part of the process. Electronically, we're putting the documents as we record them. We're recording the book and page in a database, a SQL database, indexing it, and then it can be searched by any member of the public. Traditionally, we would put them in these 3-ring binders on a shelf, and we have, however many, 19,000 corner records that we're preserving. We are still actually printing a paper copy of the electronic files and putting it in these books, just as sort of like a matter of, we're doing it. We don't really need to do it legally, I don't think, but we are doing that. But the electronic version is superseded all the paper that we would have done in the past. And then we publish this to the public. This is the web portal that we use. If you were to look for that under AlamedaCountySurveyor.org, no, that's not right. If you were to search Google Alameda County Surveyor, you would get to this website. And that fulfills the requirement of distribution to the public under the Code of Regulations 464F. So in our experience, what we've done is kind of the least expensive, least difficult way of using the tools and resources that we had at Alameda County. Different counties will have different resources, and if you had unlimited resources, it might be possible to go through a more sophisticated process of doing electronic corner records and using digital signatures where both the county surveyor and the submitting surveyor would sign through something like DocuSign. That it is possible, but that would be much more difficult than the process we've developed at Alameda County. So it will continue to improve and evolve. Electronic recording is not always an improvement. You know, there are some downsides. We talked about the attribution, the data integrity. You know, you do have to sort of figure out a way to maintain those things, whereas with paper, it's much more established how that process would work. That's it for my presentation. Do we have any questions, thoughts, comments? In the back.
The paper trail part of it that you...
You want to take the microphone there?
The paper trail part of it that you were talking about when you were saving the paper before electronic, how long did you save that? Is this get saved forever like a quarter record?
Yeah, so the question for anybody that didn't hear was, how long are we saving the paper copies? Is that it? So under California law, I think the intent was that they be preserved indefinitely, just like the recorder would record deeds. You know, there's no limit on when they would stop recording those things. I don't really, I would a conversation with a recorder and find out what do you do with all the paper copies, because I know they ship them off-site and archive them. So what do they do with those? Are there archival standards that maybe we should be thinking about as county surveyors, like maybe we need to also adopt that for corner records. For the electronic corner records, we have a system of backups and redundancy. I would like, I'm considering in Alameda County having a hard drive created every year that just has all of our data that we put in our vault with our paper files, so that if something were to really happen and all the IT stuff doesn't work, we could go back to our vault and we could find the paper field notes from the 1800s, and we could find a hard drive from 2026, and theoretically you could still recover the data.
You mentioned the recorder, but most recorded documents get mailed back to the grantor, grantee. Are there other documents, I'm curious, are there other documents the recorder keeps besides maps?
So in your experience, is the recorder actually sending you back the original? It's not a conformed copy?
Yeah, when you refinance a house, you have a new deed of trust, you get that document back.
Okay. So they must have gone to a system
when
where
recorded and mailed to, they mail it back.
Yeah, so they've gone to a system where they are no longer housing the paper files.
They're recording it.
Right?
Posterity,
right.
Mailing back the original.
Now, as far as I know with maps, those are still, the hard copies are still being preserved by the recorder, so.
Because those are filed, is what I've heard.
Yeah, yeah.
So the difference between a recorded document and a filed document is filed stays in-house. Corner records are filed in your 3-ring binders.
Right.
And the recorder records a copy, if you will, and sends back the original. That's the way it was ever explained to me.
Yeah, so at some point the recorder, it'd be interesting to look at the history of recording in California. At some point they stopped keeping those paper files. And I don't know what year that was, but yeah. Any other questions? Yeah, in the front.
They've always been there. They're always been.
Really, even on the old handwritten field notes, you think those were? Yeah, but I'm saying like in 1906 when the San Francisco fire destroyed all the recorder's documents, the problem was that they lost all the original documents.
What he's saying is that the scriveners, they would just write it out and have that in a separate book.
So what the recorder had that got burned in the fire was the recorder's copy of the document. Everybody that got back to the deed,
right.
If they had a copy of the deed, they would go up to the house, they would bring that into court and say, here's my proof that
right.
Right.
Right. So, yeah. I don't know if everybody heard that. Did everybody hear that? So let me repeat that, what Dave was saying, because I think it kind of tells into what we were talking about before. So Dave was saying that the recorder has always made like transcribed copies of all the documents that were being recorded. And that's what was lost, like in the San Francisco fire, it was their copy of all the original documents, but they weren't storing original documents. So, you go ahead.
Yeah, I'm taking advantage, asking a county surveyor in a different county other than what I work with. And I've had an experience recently of monument conservation before a construction project tying out monuments. I turned in the corner records and the county surveyor refused to sign them because he thought it should have additional information on it. So I thought he went a little bit overboard. I thought my information was sufficient to tie the monument out and to put it back in. So I'm just curious as to what your thoughts are on something like that.
Well, I've only been a county surveyor for about 9 months. So I will say, wherever I stand, I'm probably going to change my position over time. I do think that there must be, that the county surveyor's role as being the recorder and the reviewer is a little bit different than just like the recorder's role of accepting a document and recording it. For an 8771 corner record, I don't think the standard is very high because you're basically saying there's a monument here, I'm telling you what the status is today, and that's really the only purpose of the 8771, as opposed to an 8765, which is basically a full-on survey. So without looking at your 8771, I mean,
I realize I put you in a position, but I just thought I'd ask.
do you want to tell us like what kind of comments you were getting back? Were they like,
very similar to the example that you showed us up in your presentation here. I had 4 swing tied or 4 tie points. We were doing pre-construction, so we're just tying it out very quickly, not resetting it. And we would pull a tape to the ties, mark that down and submit it with the 4 distances. And the county surveyor said it wasn't sufficient. I had to have interior angles and I had to have other monuments tied out, other street monuments tied out on that corner record. So
yeah. So on your swing ties, are you saying line of sight? So you'd have a straight line with 2 endpoints as RPs?
That's that he wanted.
Yeah. Well, I mean, I will say that I don't know the answer to your situation, but I do know that when I was looking at 8771, I was interpreting all of the provisions of 8771 as one coherent section under the law. And part of that you could interpret as saying, like, you do need to show ties to other street monuments. I think it's the 5th or 6th section down there. But when I talked to Rick and Dallas at the board about that, they explained that that section has been like pieced together over the years and that those lower sections were never intended to be sort of interpreted in the light of 8771A. But, you know, I could, you know, as an attorney, I could understand how you might have a different interpretation of what that section of the law means, and maybe that's where the county surveyor was coming from. You know, if that's the case, I'd try to talk to your local CLSA chapter and just say, hey, this seems to be an issue. Can we kind of have a talk with the county surveyor and see if, you know, what the explanation is? And if necessary, you can talk to the board about their interpretation and see if that would help. But,
thank you.
Yes?
Yeah, George Marchenko, the contract county surveyor, First Small County, San Benito. My understanding is that the county surveyor can disagree because there's a place for county surveyor's comments. So there's some, ultimately the county surveyor, if you wanted to force file a corner record, you could, but it would not necessarily relieve you of an obligation. It would not relieve you of an obligation if you were required to file a record of survey by force filing that corner record. A little bit off topic, but the thought came to my mind.
Yeah, that's a good point. I mean, there is a place on the form for the county surveyor's comments. So, honestly, we've never had a situation where an 8771 came in that we disagreed about. You know, there are things that we say, like you forgot a north arrow, or they're very technical requirements, that we send it back. But those are never, we haven't had a situation where those were in dispute between myself and the submitting surveyor. Let me, Magnolia.
I'm the Tulare County surveyor, and we kind of, echoing that, we do, if it comes to the point where we disagree, you would just, until we didn't come on agreement, you would just basically say file it, and I'd put a comment if I disagreed, and then it would go to the board if it was so severe that I thought it was necessary. But that's not what I was going to ask. When it comes to like setting this up as far as intent, did you do any initial submittal, like saying, hey, I have an intent to submit these digitally, so you have their signature and all that kind of stuff tracked, or did you consider doing something like that?
Are you saying when they submit the initial request for like an 8771?
I'm talking more like you get a new surveyor in the county and they kind of just register that they're going to be doing this, and this is like their signature, and just kind of to outline that, because we've been having this kind of same thoughts about how to handle digital signatures, electronic signatures, and that's kind of what prevented us to do it so far, and this has been very helpful today. So
yeah, and I will say that prior to my tenure, the county had been pushing to go electronic. So I would say 99% of the surveyors in Alameda County are comfortable using email, and that's how the communications happen. So with that in place, there are one or two surveyors that still, although they have email, they don't use it. So we still have surveyors that will submit paper, and I will call them if I need to talk to them because I know the email may not be answered. So we still have to adapt to, doing it in paper, but we'll scan it ourselves if that happens, and we'll try to document, to the same extent that we normally do, the intent they did submit a package. This was the materials that was in the package. Yeah. Magnolia.
Yeah, I guess we're both standing. I guess I was wondering about seals in addition to signatures and how those would be handled, if that would still just be kind of added, as artwork and then a digital signature, or what role, I guess, a seal would play at that point. And as a secondary question, does it sound like you want to continue with a hybrid modality of hey, my computer's not working to send this email, here I mailed it to you instead? Is that still an option?
It is still an option to mail it in. We're working on an electronic payment portal, which if it comes online later this spring, which we are fingers crossed, that will kind of change this, because basically you'll be required to pay through the portal. And I'm anxious or interested to see how many surveyors push back and say we can't use your electronic payment portal and we want to send you a check. There may be some surveyors that want to do that, and we'll have to accommodate that if that's the case. But I believe that for most surveyors, that electronic payment portal will be so much easier, and it will include the submission of their documents, that most people will want to do that. And then the seal, right now you can submit electronic seals. That's totally legit. I think where I see a lot of issues right now with surveyors is they submit documents sealed, but they don't say that it's preliminary or in progress or draft, right? And that's clearly a violation of the board rules. And it's also confusing to people that get the maps, because potentially they see a sealed document and think, oh, this might be useful for some final purpose, when it's really not. So I think it's probably more important to emphasize, make sure you put that preliminary stamp over your seal or on your signature block before you send anything out of your office. But the seal is okay to be done electronically.
Yes, I've been doing some surveying in the city of Berkeley, and I went on your website and I got several corner records filed in 2025, and it was surprising to me to see elevations on all of the corner ties and the monument itself. with elevations and a note saying city Datum. I was curious about that.
Yeah, I think we would need a representative of the city of Oakland. It was Oakland or Berkeley?
Berkeley.
City of Berkeley to explain that. But I suspect there's something that the city is saying, like we would like to see the benchmark perpetuated in the area.
I thought they had nothing to do with corner records.
Well, they don't record them, but they can require them as part of a construction project.
Oh, I see. If they require it, they could add that on. Oh, I see.
Right. Yeah.
I can't answer for Berkeley, but for Hayward, a lot of our benchmarks are monuments, street monuments. So when we reference them, we generally will reference the ones that are benchmarks with elevations on the RPs as well. So when we reset it, we can put a good elevation on there and then update our benchmark system.
Right. Yeah, that makes sense. Any other questions?
Okay. Electronics signature versus digital signature. I never thought of there being a difference, but I want to see that I understand it. When I put my stamp and a photocopy of me signing a paper on it, that's digital.
That's electronic.
That's electronic. Okay, that's electronic. Less secure. If I sign into Bluebeam, put my password in, and it says digitally signed by Antonio, blah, 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 that's a
digital.
That's a digital signature. Okay. Nothing, like, no document's going to get recorded at any recorder around here where it says next to the stamp, digitally signed by Antonio, which I put on ALTAs all the time or whatever. Okay, so, well, I wanted to see the codes you put up again because both of them are, either version of that is legal, you're saying, because you had code references. So that's 16332 and 2200. Okay. Where else was I going with it? I don't know.
Well, let me just say that we do have corner records that are filed with a digital signature, right? So the guy does sign it in Bluebeam, and it says signed by Antonio, whatever, right? He prints it and sends us a PDF of that. That's no longer a digital signature, it's just now an electronic signature.
That's kind of what I was asking too. So then the only way for you to get both, because the only way to get both mine and your digital signatures is I would have to set that document up ahead of time.
That's right.
To accept two signatures.
That's right. And then we would have to accommodate somehow the recording and archiving of that document that in a way that doesn't mess up the digital signature.
Yeah.
Because what we found is when we put it into our SQL database, it manipulates the document somehow. Maybe it adds a header or something, or it changes, it does something, and it invalidates the signature.
You know, I mean, like there's a data side of at least the use Bluebeam as well. There's a data side that will tell me if it's invalidated or if it's a valid signature. And so, I mean, are you capable of turning an electronic signature into a digital signature? Because I've figured out how to add passwords to it to the point where I've got clients complaining that they're not able to edit my legal description. And so, I mean, I don't know how secure the whole thing is, but at least I'm like, okay, you're asking to edit, you're complaining that you couldn't edit something that you shouldn't have been allowed to edit, so it's working to some degree, okay?
Right.
But.
And that may be appropriate for some context where you want to give something to somebody, but you want them to know that it's been altered or changed. So having a digital signature permits you to do that.
Right.
If they do any editing, it will invalidate the signature, and it won't continue to show your name as being the author, right?
Right.
But for purposes of making something legally enforceable, as though you've signed it, it just needs to be an electronic signature and meet those intent, integrity, and attribution traits.
Yeah.
So you can go from digital to electronic, but I don't know how you could go from electronic to digital. I think that's probably not possible. Any other questions? Magnolia, you look puzzled.
Is it that hard to print it out
So Magnolia's question is it that hard to print it out, sign it, scan it, and then send it back? The answer is that's fairly simple, right?
Yes.
But,
It's 2025.
but I think, but I think the point is, why do we have to print it? I mean, and then sign it and then scan it. If we're doing the same thing inside the computer, like could I as the author, as the receiver, tell whether you printed, signed, scanned, and sent it to me, or you just signed it on the computer? Like, I don't think I can tell as the recipient whether you did it one way or another. And the point, I think, of this law was, and this was a national model law that California adopted, is that, you know, we're in the age where if we think that it's legally enforceable to print, sign, scan, and return to somebody, it should be also legally enforceable for me to just sign on the screen and return it, and skip the printing and signing and scanning. So this law just made that sort of explicit. Yes?
So just to reemphasize, printing, signing, scanning results in an electronic signature.
So Dave commented, printing, signing, scanning results in electronic signature. Yes, as long as intent, integrity, and attribution are maintained. Yes, sir.
But you're saying sending it off the corner record, if it stops with you, right? You file the corner record, they don't get the original back.
That's right.
Okay. Just want to clear on that. And he answered his question answered my other one.
Okay.
So is the major roadblock to digital signatures the accommodation from the counties to have a document that doesn't invalidate once another party, like a county surveyor, is deciding to sign off on it?
Yeah, it's that the digital signature requires that encryption key that's inherent in the system that's creating the key. And unless both the county surveyor and the submitting surveyor have some sort of agreed on mechanism of doing that, once one signs it and then submits it and the other tries to sign it, it invalidates the first signature. So there has to be kind of a package. And then of course for recording purposes, there has to be a way of taking that digitally signed document and archiving it and also not invalidating the signatures. Like we would not want to have archives where when you print out the corner record, it shows the county surveyors and the submitting surveyor signatures as invalid.
Is there a software that exists that would accommodate that, or it just requires adoption?
Well, I know that DocuSign could be used that way. You know, I could send you a copy, say, of the corner record that you submitted, that you said, this is ready for Mylar, and I could send you a DocuSign copy of it, and I could say, okay, now sign it yourself, and then I would sign it, and I, as the county surveyor, would receive the end document that had two signatures that were both valid. But we don't have DocuSign set up that way in the county. And like I said, in the recording part of the process for us, the software manipulates that image in a way that it invalidates the signatures. I was trying to do that, you know, just for my signature. Could I just digitally sign it and record it and archive it? And we couldn't, that was a problem. It was a hurdle. So I'm sure there is a way that it could be done. We just didn't have that capacity in Alameda County.
Sorry, just another question then on the back end. If someone goes onto the GIS portal and downloads the corner record, will they appear as digital signatures, electronic signatures? I downloaded, I printed out to put in the folder because I'm going out in the field. Does it show the DocuSign version? Like what is, I guess, the back end part of that look like?
So for our purposes, when it's printed, it looks just the same as it was submitted to us prior in paper versions. So you wouldn't know the difference. Now, for the surveyors that I mentioned that have submitted a digitally signed corner record, you would see it says digitally signed by, and it's not invalidated, but that's because it was a scan of the print of their, so it's not a digital signature anymore. But it still works as far as, you know, it still meets the elements of attribution, integrity, what was the third one? Something. Intent, right. So I don't know how we're doing on time, but I can go on all day if you guys want to keep asking questions, but we may be out of time. How are we doing on time?
I think we can close, we're 18 minutes behind, so I think we can...
Sorry, everyone.
Close these questions, but if we could all give a round of applause to Mr. Mabry.
It seems we're taking the microphone out, so we're going to follow the tradition here. My name is Josh Carpenter. I'm a professional surveyor from the state of Ohio. For those of you who were in the beginning session, that's the state with 89 new zones. So I teach at the University of Akron in our surveying and mapping program there. So that's a little bit about me. So what I'd like to talk about today, what I want to present to you today, is it's a platform that I hope will help us as a profession, surveyors, be a little less covert. What I mean by that is, my first day on the job at the University of Akron, one of the senior faculty members came up to me and said, "Josh, I want to welcome you here to our top secret program where we train our surveyors for the top secret profession." People just don't know what we do exactly, and much less consider it as a career. And so I hope that we can be a little more overt in what we do. So I want to talk a bit about what the problem is specifically. The problem is what this program attempts to do, what this project attempts to do, is to expose people who have no idea what boundary surveying is to boundary surveying. I first ran into this problem when I was a grad student at Purdue University. I was tapped to teach an engineering boot camp. It was a 5-day boot camp. High schoolers from around the country were bussed in, and we had them for 8 hours a day for a whole week. And there were 4 disciplines we talked about: hydrology, structural engineering, transportation engineering, and then for me, I was teaching the geomatics engineering part of this. And I wanted to show the students something about topographic surveying. I wanted to bring out the drones and show them drone surveying. But then I would be remiss if I left out something about boundary surveying. It's such a core part of what we are and why we are licensed. But this is where I kind of run into the problem of, like, how do you take high school students and in 2 hours give them any kind of experience which lets them say, you know what, maybe boundary surveying is something that I want to do. When you think about it, there's a lot of jargon that someone would need to know, maybe even just to read their first deed, let alone do an exercise in boundary surveying. There's just a few more. I remember the first time that I read a deed and it had the word vents in it. I was like, is this English class? Like, the last time I heard vents was in Shakespeare. And so there's a lot that needs to be covered. I throw a little graphic on there, iron pin. So I don't come from a surveying background. My undergrad was the first time I heard about that. Every time I heard a pin, I just thought something you use for sewing. It was just an odd thing. There's a lot of stuff, a lot of nuance there. One of the big problems that we have is our education system for educating surveyors is very siloed. We take this approach that we're going to pick a particular discipline and you can learn about boundary law, and then you can learn about precision measurement, and then you can learn about field work. And you put all of these together, and history, a lot of history, right? Put all of these together and you get surveying. The thing is, what makes boundary surveying so beautiful and what makes it unique amongst all the disciplines that you can do is really the synthesis, the joining of multiple different things. It's the intersection of law and history and expert measurement. And this is a combination, a cocktail, which you don't get in other fields. And so you want someone to be able to operate in that field. You want to teach, allow students to experience surveying without having to understand the constituent parts of boundary surveying. It's kind of like trying to convince someone, hey, apple pie is really good, and then teaching them about apples and cinnamon and the tools that you need to bake. No, you really just need to give them a piece of apple pie. Say, taste it, taste it. And I threw up there a question from the Fundamentals of Surveying exam, which kind of demonstrates how we treat surveying education. It basically is just a question about priority of calls. And what I want to highlight here is the siloed approach we take is good. We're trying to train people to be professionals. It's a good thing that we do it that way. It's just not good when you have 2 hours with high schoolers. What I wanted was something that was intuitive, something that would allow students to play, to kind of understand, and to get at the core quickly without understanding without having to understand every bit of nuance. And I think a good example of that is the projected contour sandboxes that you see, where you can pick up a scoop of sand and dump it, and you see the contours reproject around that scoop of sand. And it gives you an intuition about how you capture 3D information on 2D without understanding things like tins and interpolation. So that was the motivation of the project. I want to talk a little bit about the development. I had in mind students gathering around maybe a table, just a big map in front of them, something like a board game or a war game or something. And then it would be a map of like a town with custom boundary conflicts that they could look at, with documents off to the side that they could dig through that have been simplified for their level. Their deeds, plats, parcel maps. By looking at the map, they could see sign of occupation. Maybe a grid system would allow you to do a lookup to find monuments. And then you could measure directly on the map to plot things and to do some digging around to see if there's any monuments. Mainly, it wanted to be focused on interconnected decisions. A boundary resolution that you make in one part affects something else. There's a context to every question. And that context needed to be captured. And finally, something that was a tool that would help me as the instructor walk students through the thought process of deciding creating some of these boundary resolutions, focused on guided discussion. The main thing was I wanted to be able to integrate the evidence, the history, and the geometry that are all pieces of boundary surveying. You can't take one, you have to have all of them together to experience it. So it started out with a rough sketch of where I wanted to go, and then slowly built up a history for this fictitious town, from the original deeds, from the original patents, all the way up to a modern age. Drawing, plats, writing deeds. It's a little bit difficult. It's a very backwards way of thinking about surveying for me, to think about, okay, I know what the right answer is, and now I need to introduce kind of errors and overlaps and measurement problems to cause issues in the future. Learned about vector art, so we could draw the maps and see, all right, now here's what's the top-down view of this world look like. And so this is what it ended up looking like. This is the map that they would begin to do boundary resolution on. You can see that there's evidence of occupation like walls and fences, bushes and shrubbery. There's also a grid system. I didn't want students in their measurement to get kind of obsessed with exact angles and distances. So there's a grid system where you lock into particular points on a map, and then you can look those up, see if there's any monument at those positions. That also simplifies the solutions, because all corners fall on a particular grid point. That means there's not an infinite number of solutions, but there's a limited number, especially on an angled boundary line. So at the end, it covered about 140 years of history, starting in 1800. I wanted to go all the way up to the current day, but I just ran out of time and ended at 1940. So that's why that date. The exercise has 19 recorded surveys, 2 unrecorded surveys, 50 deeds, and 2 parcel maps. So that was the material. I wanted to show a little bit about how the simplification can be done for some students. So if anyone wanted to use the material, it's all freely available online. You can definitely use it. So a view under the hood, the recorded surveys include things like subdivision plats, consolidation plats, splits, first surveys, splits following occupation. Deeds contain examples of meets and bounds descriptions, bounds only descriptions, descriptions and exceptions, survey by reference, meets and bounds creating divisions with a survey. But the students don't need to know all of these different distinctions. This is just for those who understand what's under the hood. For a student, all you need to know is that, hey, your recorded surveys, this is what is affecting the parcel lines. You're either creating new parcel lines or you're merging parcel lines. This is all that they need to know to start. For the deeds, all you need to know is that the deed is the document which transfers ownership between people. And sometimes they create a parcel line. So you can take these multiple concepts and collapse them into a very simple principle which a student can then begin to apply as they interact with their fellow classmates. Other examples, so most law can all be, in fact in this demonstration, collapsed all of legal law into just one principle. You cannot convey that which you don't own. So you just check what does this person own, can they convey that? And that underneath of that is many different surveying principles such as sequential conveyances, simultaneous conveyances, junior senior rights, priority of calls, etc. Some things had to be completely just dropped for simplicity. So no discussion of area, there's no curves in the assignment, there's no basis of bearing, everything is off true, grid, north, whatever. It's all the same. There's no easements. There's, importantly, especially in California, no public land survey system in this simulation. And the list can go on for that. That just gives experts an idea of the kinds of things that you could interact with. But again, the students don't need to know all of these distinctions. This is just for those who understand. I want to talk a little bit about in the classroom. So when we took it to the classroom, the very first thing we did is a little exercise where the students were given a verbal description of a corner of the classroom that they would own, and then they had to write a legal description however they wanted to, and they could use whatever they wanted to do monumentation. And that allowed them to sort of begin to understand what we're trying to do. There's things that exist in the real world, and we need to document where they are. And so that's what you start with. And then you can bring up examples of, hey, what you did here in the classroom, moving a chair to a particular corner of room to mark your corner, using a tape measure, we do that in the real world. It's the exact same thing. People have property, they like to mark it with fences, we like to put things down to show us where the corners are. And then from that, we moved into actually using the simulation. As I said, paper and pencil. I'm going to give you a little demonstration of some of the things that can be done with it. This will just be, I'll go over this quickly for time's sake. One thing I need to do is have an exercise so students could understand the history of documents. We are very history oriented. You need to build a timeline, you need to understand the story of a particular parcel. So we started out by identifying this parcel in pink, which is all owned by one particular family, the Goldmans. We start with the current deed, and then we put a timeline down and say, all right, let's put this on a timeline. A deed just drops us in the middle of the story somewhere. Now, let's learn how did this parcel get this shape? Which means land doesn't start owned. It starts as just one big continuous bit, and then you need to trace back when there's a line, and it splits between owners, there must be a time in history when it was owned by the same person on either side. So for every line, just trace it back until you find it owned by the same person on either side. So this takes them through the register of deeds. You can see, okay, the Goldmans got it from the Kerrs, and I'll jump through this a little bit for time's sake. This doesn't give us any new information, so we go back even further. The Kerrs got it from the Hoolers, and so on. You build up a timeline of tracing this piece of property back until you have one common owner, as I'll show here. So now we finally found the place where we have one owner for the whole bit. And then we can ease into, here's a subdivision. Here's where the lines were actually formed that break up that parcel. And then we can see we still have two more lines that we need to solve. We need to figure out where they were built. And so you trace things back to get the documents. And let me get to the punchline here just for time's sake. And so you build up a history, a timeline at the bottom here, which the students can see, okay, now I understand what's happening. We have one piece of property gets sold off and split, and here's the order of events for that piece of property. And, okay, I'm going to show a little bit about some other features, but I'm going to do that in a different setting. The exercise went off really well. Had great feedback from the students, and one student said, you know what, this would be really great as a game. And I thought, oh, that would be cool. That would be cool. Let me see if I can move this online. Maybe it's material that can be used more widely. And so since that boot camp, I've been working on moving this material all to an online platform. And that's what I'm going to demonstrate right here. So it's available online, free to use by anyone. You can navigate around online, zoom in and out. You have the map. I'm showing you some of the streets, the buildings, some of the areas, the evidence of improvements, different kinds of buildings and things. You'll notice it's an island, and that's just because you have to kind of end things somewhere with a natural feature. All right, we will end my little demonstration here in a second. So, I'm from Ohio. We use monument boxes a lot. I know some states don't, but those are featured prominently, and that gives a tie for students to begin mapping information they see in the documents to information on the ground. Drop downs give you all the records, and there's 10 prompts. So there's a tutorial that was written up that walks you through some of the documentation and how to look, how to navigate, how to begin thinking about a land issue. So that's there. And then there's 10 different prompts that just give you a problem. So I just pop up one here. It says, this person wants to build their garage. Is that fence the property line, or do they own something further? And so then you have to go back, find the current deed. Here I am going to the current parcel map. That's kind of like, county GIS. You look up the deed reference. So the students can see that there's a particular name for the parcel and a deed reference, and you can go back and take a look at the current deed. In the online version, the deed opens up in a side window here, so you'll see it pops up off to the side, so you can see concurrently the map and your deed that you're working on. Deed's very simplified just to the legal description. That's the only language in there, because again, we're trying to keep it simple. But this allows you then to begin reading things and plotting in the world. So you're actually making a search for the particular thing that you're interested in. Here it starts at a monument box. You can use a little digging tool to dig in and see what kind of monument's there and get a little description, and then begin plotting out the legal description. This happens to be meets and bounds, but as I said before, there's a lot of different examples here. So in this example, we decided we want to search at the fence corner to see if there's any monument, get my little digging tool, and then you can see a little pop-up picture. Yeah, I just grabbed this from the neighborhood. I just saw this and uploaded that, but it matched the setting right. So you can plot this out, and you'll see that it allows you to see how does that legal description fit on the ground. What you'll see in the next bit of the demonstration is that you can also pull up the surveys, the plats that have been recorded, and you can do the same thing. This particular prompt, the issue is you have quite a large overlap between the description in the deed and a neighboring survey. So that's the crux of the problem that they have to grapple with, two conflicting descriptions. I try to make things a little easier. There's references within the deeds to the specific surveys, so you can find them. A lot of the surveys in the demonstration also have a lot of information about the evidence of occupation, especially historically. So you can see that also pops up. Yep, just grabbing the plat reference. Pre-record video is almost done. And so you grab the plat reference right there, and you can take a look at that side by side. So all the material is there, available online, and anyone can play with that. So I wanted to just talk last minute here, talk about the future goals. So a lot of paths I could go next. One of my goals was to make this an outreach tool, something like I said, like a sandbox. In some regards, I think it did well. In other regards, I still have a desire to simplify a little further, something that could be used at like a booth at an event where you have people up there for just 15 minutes. So something that can be a little more interactive and a little simpler that way. In my experiments, this works best when you have about 2 hours. You can really get into some problems when you have about 2 hours with students. The next thing is that I've used it a little bit in my classroom for college-age students and found it to be quite useful as a tool. If anyone's interested in using this material in a certain application, let me know. I'd be very interested in seeing how that works out. And I would also like to build another simulation specific to other areas. I know like public lands would be one that would be great to have a simplified version that you can kind of get the basics of public lands. So that concludes my talk. As I said, I'm very interested in developing this further. If anyone is interested in the project, wants to contribute either in ideas or in support of some way, I'd be very happy to talk to you about that. Thank you so much for your time.
All right, and then were there any questions for Mr.
You want to come over to my place and teach my wife some surveying? I thought that was really fascinating. This is not a real town. You came up with all these deeds, is that correct?
Yeah, it's entirely fictitious. The problem is you can't get all the problems you'd like to expose to students kind of compressed into an area. And so, yeah, this is entirely fictitious.
Yeah, kudos. I think that's pretty cool. And you get a little Mario Brothers or something. I don't know. Pac-Man's the new bulldozer. Just throwing some ideas.
Thank you so
Good
much.
job.
Yeah, appreciate it.
Why Nervair?
So I've been called a nerd sometimes because I did a PhD. So yeah, nerd surveyor. There you go.
What group size is this going to work best with?
Yeah, so when I used it with students, I've mostly been working with people that I can interact with. I did teams of 4, so 4 students per team, and I ran 4 teams, so 16 students total. Okay. And in that way, you could kind of leave them be to discuss and sort of figure it out on their own, but then also step in with some guidance as they go through the prompt and kind of directing them. Like I said, it's designed as a crutch, something for someone who's in an instruction position, perhaps like a Boy Scouts or some other boot camp of sorts, to be able to guide through the material. And so I found that best to kind of allow them to explore a bit, but it's not self-guided, so you do need to step in from time to time. So yeah, 16 to 20 kids.
Okay, so I went to the website that was up there. You want us to use it? It's okay to use it?
Oh yeah, of course. I even have put the material, like the PDFs, in the public domain, so so that it's clear legally that anyone can download, use it, whatever.
Yeah. This is not a thing that I personally like to do that much, but I'm talking to being roped into doing something on Tuesday. So instead of coming up with my own outline on the drive down to Visalia, I'm glad I'm sitting here. So I'm gonna,
yeah, I'd be very happy to give you a more thorough demonstration if you're interested, or hear about your experience if you do use it.
I will. Yeah, this is great. So 4 to a team. They just need 1 computer. What?
Yeah. So actually, when I did it with that class that I was talking about, 4 to the team, I was doing that as a paper. That was back when it was still paper and pencil. Okay. For the computer, it sort of depends what your resources are. I've done it in a computer lab where each student had their own computer, but still kind of grouped them by table.
Yeah.
Because it's best when you have a lot of collaboration.
Right.
I've never run it with just one computer to 4 people, but I'm sure it could be done. The main issue is you just need to have, the students need to be able to think of something in their head and then grab the documents that they're interested in. And so if you have one person who's hogging the computer and you can only view one document at a time, it sort of can limit things a little bit. But if you have other resources like mobile device where you can read through it, or perhaps you can print off some of them, then...
Well, yeah, I guess they all could be on their phones. They'd like that, right?
Who's going to know what they're doing?
Right, and have one computer to 4 or 5, I can probably do that.
Yeah, this is really a proof of concept for me. There's a lot of further I'd like to do, but it's going to depend on really resources. So,
well, good job. It looks amazing.
Thank you. Appreciate it. That was interesting.
Did you have an idea of the next town or concept, whether it be another subdivision or public land township division? And if you do you have a timeline on when that would then be rolled out?
Come on, man. Yeah, right. Yeah, so I think the exact vision for the next step is going to depend on sort of who I'm able to partner with, because I'm at the point where it can't just be a nights and weekends project anymore. It's got to be something where I can make it profitable in some way. Not necessarily profit for me, but at least that I can fund it. What I'd like to do, I'd like to integrate this with my teaching at Akron and actually build a small team of students that would be on the development side of things. But of course that takes a certain amount of funding. But that's what I'd like to do. Public lands would be my next step. It's where I think within our program we could definitely use some more material on that. So that would be my interest.
Consider it a board game. Possibly a board game. I'm not doing it, but your students could be fun.
Yeah, so far it kind of gives you that board game vibe, but it's definitely not gamified yet. But yeah, maybe in the future I would not be opposed to it.
Are the 10 prompts independent of each other, or do they lead to like an ultimate conclusion?
That's a great question. One of the core design principles that I wanted to build, what I thought was very much lacking in the surveying education currently, is the interconnectedness, because we'll have a question which asks, like I put on the board, would you hold the monument or the distance? And it's like, well, I know that question is asking me about priority of calls, and that monument is held, but given in the real world, there's like a whole context to these things that really matters. And so the idea was to bring in the context. And so since it is a closed system, a decision you make in the beginning, the first prompt, is going to affect what you do later on. The prompts are set up so that they're actually kind of ordered by the degree, sort of by difficulty, but difficulty is just how much of the world do you have to explore to answer the question. So the first ones, you only have to explore the world a little bit, and as you get deeper in, the questions start to tap into older and older documents, which affect more and more of the simulation. Okay, well, thank you so much for your time.